Hello, check. పంపించండి. Can I start, sir? Sir? Murli sir? Okay. Good morning, children. Welcome to Nandi online classes. We are under the concept of maxima minima. Yesterday we started working problems. Let us continue the remaining problems. Right. Page number 233. Page number 233. Put textbook in front of you. Last class 19th problem was over. Now write 22 problem. 22nd. A wire of length 28 meter is to be cut into two pieces. One of the pieces is to be made into a square and the other into a circle. What should be the length of the two pieces so that of the square and the circle is minimum. Right. Solution. Understand the question. Right. A wire of length 28 meter is to be cut into two pieces. A wire of length, one wire is there. It is of length 28 meter is cut into two pieces. One of the pieces is to be made into a square. First piece is made in the form of a square and the other into a circle and the other piece made in the form of a circle. What should be the length of the two pieces so that the combined area of the square and the circle is minimum? See that one wire is there, it is cut into two pieces. So let us assume that AB is a wire. AB is a wire of length 28 meter. Length is 28 meter. Okay, is cut into two pieces. Is cut into two pieces. AC first piece, BC second piece. First piece, second piece. First piece is made in the form of a square. Is made in the form of a square. Second piece is made in the form of a circle. First piece is made in the form of a square. Second piece is made in the form of a circle. What should be the length of the two pieces of the wire? So, what is its length? What is the first piece length? What is the second piece length? We don't know. I am assuming. Let the length of first piece of wire is x meters. AC value. First piece length I assumed x. Second piece automatically becomes total minus x. So 28 minus x. Total length is 28. So this part is x. This part is 28 minus x. If you add them, plus x minus x cancel, total is 28. So first piece is made into the form of a square. Square means side will be there. So let us assume that A be the side of a square. Circle means radius is there. Let R be the radius of a circle. Like that we are moving. According into data, combined area of the square and circle is minimum. What is the area of the square? Area of the square is square, side into side. So A square. Area of the circle is pi r square. Like that we are moving. Draw the figure. Okay, write down. Given length of the wire, comma AB is equal to 28 meter. AB is equal to 28 meter. Let the length of first piece of wire. First piece of wire is equal to x meter. Then length of second piece of wire is equal to 28 minus x meter. 28 minus x meters. Okay. Now the perimeter of which is that this is a square. This is total is called perimeter. What is perimeter formula? Perimeter of a square is 4 into side, 4a. So perimeter of a square is equal to 4a. 4 into side is a. So but perimeter says total length, this total length is nothing but first piece of length. First piece length is x. That wire only is made in the form of a square. That piece only made in the form of a square. So x is equal to 4a. A is equal to x by 4. A is x by 4. So perimeter of a square is nothing but first piece of length. First piece only made in the form of a square. Right. Perimeter of a circle. Perimeter of a circle. We know that perimeter of a circle formula is 2 pi r. 2 pi r. See, perimeter of a circle. Perimeter of a circle. It is nothing but second piece of length. Second piece of length is 28 minus x. So 28 minus x is equal to 2 pi r. Then r is equal to 28 minus x divided by 2 pi. 28 minus x by 2 pi. Perimeter is first piece of length. Here perimeter is second piece of length. Now combined area of the square and circle. combined area of the square and circle. So area na, so denote by a. What is area of a square is side into side, a square. What is area of a circle is pi r square. So combined area means addition. So a square plus pi r square. A is equal to, we know a value, a is x by 4. So x by 4 whole square plus pi into r. R value we know 28 minus x divided by 2 pi whole square. R value 28 minus x by 2 pi whole square. Right, simplify. A is equal to x square by 4 square value 16 plus pi into, take square to both numerator and denominator, 28 minus x whole square by 4 pi square. 4 pi square. Okay, here 1 pi cancel. A is equal to x square by 16 plus 28 minus x whole square by 4 pi. 4 pi. Okay. According into data, combined area is minimum. So we have to apply maximum minimum method for this area function. Apply maximum minimum method. It is involved in x variable. So differentiate with respect to x on both sides. So dA by dx is equal to 1 by 16 constant outside. X square derivative is 2x plus 1 by 4 pi constant outside. 28 minus x whole square derivative, x square derivative is 2x. Like that 2 into 28 minus x into base function derivative. 28 is 0, minus x is minus 1. X square derivative 2x, base is minus 1 is equal to 2 1 ja, 2 8 ja. So x by 8. Okay, 2 1 ja, 2 2 ja. So minus 28 minus x divided by 2 pi. Plus into minus is minus 28 minus x by 2 pi. That is dA by dx. Equate to 0. So for maxima or minima dA by dx is equal to 0. So dA by dx is x by 8 minus of 28 minus x by 2 pi is equal to 0. From this we are going to get x value. Right. X by 8 is equal to, send minus term to that side, it become 28 minus x divided by 2 pi. 2 pi. 2 1 ja, 2 4 ja. Cross multiply. X into pi, x pi is equal to 4 into 28 minus x. 4 into 28 minus x. So x pi is equal to 4 into 28. 4 8 ja 32. 4 2 ja 8 plus 3 11 112 minus 4x. Okay, x pi minus 4x become plus 4x is equal to 112. Take x common, you will get pi plus 4. X common, pi plus 4 is equal to 112. Right, x is equal to 112 divided by pi plus 4. Okay, that is x value. Now f double dash x, this is dA by dx. Again differentiate. So d square a by dx square is equal to 1 by 8 into x derivative 1. X by 8 derivative 1 by 8 into x is 1 minus 1 by 2 pi into 28 minus x derivative is minus 1 is equal to 1 by 8 1 ja 1 by 8 plus 1 by 2 pi. Substitute x value at x is equal to 112 divided by pi plus 4, comma d square a by dx square is equal to, substitute x value in second order derivative f double dash x, so it becomes 1 by 8 plus 1 by 2 pi. See that there is no x to substitute. 1 by 8 plus 1 by 2 pi, total positive, so greater than 0. If it is greater than 0, what can you say about area is minimum? Therefore, area is minimum. Therefore, area is minimum when x is equal to 112 divided by pi plus 4. So we proved that combined area is minimum. What they asked, what should be the length of the pieces of wire? What is the first length? What is the second length of the piece of wire? First length we assumed as x. X value is 112 by pi plus 4. First piece of length x we assumed. So length of first piece of wire. First piece of wire. Length of first piece of wire, x is equal to 112 divided by pi plus 4 meters. Length of second piece of wire. Length of second piece of wire is equal to, second piece we assumed as 28 minus x. So is equal to 28 minus x value we find. X value is 112 divided by pi plus 4. Right. Take LCM is equal to, LCM is pi plus 4. Numerator 28 into pi plus 4 minus 112. LCM pi plus 4, numerator 28 into pi plus 4 minus 112. Right. Is equal to, multiply 28 into pi, 28 pi. 28 4 ja 112 minus 112 divided by pi plus 4. Right. 112 minus 112 cancel, is equal to 28 pi divided by pi plus 4 meters. Okay, that is the length of second piece length, that is first piece length. Okay, write it. That is the total problem. Okay, write down 25th problem. Problem number 25. Show that the semi-vertical angle of the cone of the maximum volume and of given slant height and of given slant height is tan inverse of root 2. Tan inverse of root 2. Right, important problem. Okay, solution. Understand the question. Right, show that the semi-vertical angle of the cone. Show that the semi-vertical angle of the cone of the maximum value and of given slant height is tan inverse of root 2. Right, according into data, one cone is there. Right, according into data, cone is there. That cone has maximum value. Value means maximum. And slant height given. Slant height is given. Slant height means like this. Slant height given. We are going to show that semi-vertical angle is tan inverse of root 2. We are going to prove semi-vertical angle is tan inverse of root 2. One cone is there, slant height given, value means maximum. We have to prove semi-vertical angle of the cone is tan inverse of root 2. See, let us consider a cone. Let us consider a cone. Let h be the height, r be the radius, h be the height, r be the radius, l be the slant height of a cone. Semi-vertical angle. Vertical angle means angle present at the vertex. Angle present at the vertex is called vertical angle. Semi-vertical angle means this. Semi means half angle only taken. That angle we don't know. I am assuming theta. I have to prove theta is equal to tan inverse of root 2. I have to prove semi-vertical angle is tan inverse of root 2. See, theta. This is, observe that this is which type of triangle is right angle triangle. Let us name it A, B, C. ABC is a right angle triangle. Like that we are moving. According into data, volume. What is volume of the cone? Volume of the cone is 1 by 3 pi r square h. Like that we are moving. Draw the figure. Okay, write down the working. Let h be the height. Let h be the height. R be the base radius. R be the base radius. L be the slant height. L be the slant height. And theta be the semi-vertical angle. Semi-vertical angle of the cone. Semi-vertical angle of the cone. Okay, observe that ABC is right angle triangle. Apply Pythagoras theorem. What is Pythagoras theorem? AC square is equal to AB square plus BC square. So from triangle ABC, AC square, hypotenuse square is equal to sum of the squares of the adjacent sides. AB square plus BC square. AC value we assumed as L. So L square is equal to AB means H square plus BC means R square. Okay, L square minus H square is equal to R square. Take this as equation 1. Plus H square become minus H square. Now volume of the cone. Volume of the cone. V is equal to 1 by 3 pi r square h. 1 by 3 pi r square h. Make them into single variable, then only we can able to differentiate. We know r square value. We know r square. What is r square? L square minus h square. So is equal to 1 by 3 into pi. R square can be written as L square minus h square into h, since from 1, right, is equal to pi by 3 multiply h inside, h L square minus h cubed, h into L square, h L square minus h cubed, that is V. Now also two variables are there, h L, but L is slant height. Slant height given means you have to take it as constant. Here two variables are there, L, H, but L is slant height. Slant height is given, so you have to treat it as a constant. It is involved in H variable, so differentiate with respect to H. dV by dH is equal to pi by 3, constant outside, into L square is constant outside, H derivative 1, H cube derivative 3H square. Given slant height means that is given, you don't take it as a variable, that is constant 9 centimeters, like that they given. So L square constant, H is 1 minus H cubed is 3H square. Equate them to 0 for maxima or minima, dV by dH is equal to 0. dV by dH is pi by 3 into L square minus 3H square is equal to 0. Right, L square minus 3H square is equal to 0 by anything is 0. Right, L square is equal to 3H square. From this what we are going to find? If you differentiate with respect to x value you have to find. If you differentiate with respect to y value you have to find. If you differentiate with respect to h value you have to find. Right. So L square divided by 3 is equal to h square. H is equal to, send square to that side, it becomes root of L square by 3. H is equal to L by root 3. Okay, that is height. H is equal to L by root 3. Now second order derivative, again differentiate with respect to H. D square V by dH square. D square V by dH square is equal to pi by 3 constant. L square derivative is 0 because constant 0 minus 6H, right, is equal to pi by 3 into minus 6H. 3 1 ja 3 2 ja is equal to minus 2 pi H. 2 pi H. Put H value in this one. At H is equal to L by root 3. Substitute x value in f double dash x, comma, d square v by dH square is equal to minus 2 pi into h is L by root 3. Observe that it is negative, less than 0. If it is less than 0, what can you say about the function is maximum? Function is volume. Therefore, volume is maximum. Volume is maximum when H is equal to L by root 3. Okay, we proved that volume is maximum. But I have to prove theta is tan inverse of root 2. Means tan. Tan inverse means tan. What is tan theta formula in right angle triangle? Tan theta formula in right angle triangle? Opposite side by adjacent side. Tan theta formula opposite side R by adjacent side H. H already we know L by root 3. I want opposite side R. So to get R value, substitute in equation 1. So from 1 r square is equal to L square minus h square, right, is equal to L square minus h square. H value is L by root 3 whole square is equal to L square minus L square by 3 is equal to 3 into L square, 3L square, 3L square minus L square, 2L square by 3, that is R square. We want R is equal to root of 2L square by 3 is equal to root 2 L by root 3, root 2 into root L square means L by root 3. Okay, that is R. I want tan theta. So from triangle ABC, comma tan theta is equal to opposite side by adjacent side, right, is equal to opposite side theta opposite to R adjacent to H is equal to R. We find root 2 L by root 3. H also we find H is L by root 3. Okay, root 3 cancel. Is equal to root 2 L divided by L. L cancel is equal to root 2. LHS side what is continued? Tan theta. Therefore theta is equal to, send tan function to that side, it becomes tan inverse of root 2. Okay, that is the semi-vertical angle of the cone. So we proved that semi-vertical angle of the cone is tan inverse of root 2. Conclusion. Hence the volume of the cone will be maximum when theta is equal to tan inverse of root 2. Okay, that is the complete problem. Okay, right. Write down 26th problem. 26. Show that semi-vertical angle of right circular cone of given surface area and maximum volume is sin inverse of 1 by 3. Is sin inverse of 1 by 3. Right, understand the question. What is the difference between last problem and this problem also? Observe last problem and this problem. See, show that the semi-vertical angle of right circular cone of given surface area and maximum volume is sin inverse of 1 by 3. According into problem, right circular cone is there. Right circular cone. So right means perpendicular. Circular cone is there. So perpendicular, right circular cone. Not cone will be like this. It is straight, it is there. So right circular cone is there. I am going to prove that semi-vertical angle is sin inverse of 1 by 3. Theta is equal to sin inverse of 1 by 3 I have to prove. In previous problem, semi-vertical angle is tan inverse of root 2. What they given? Slant height is given. Here what they given is surface area is given. Surface area given in this problem. I am going to prove theta equal to sin inverse of 1 by 3. Same maximum volume only. What is volume of the cone formula? Volume of the cone is 1 by 3 pi r square h. Okay. Surface area of the cone formula. Surface area of the cone. Surface of the area. Surface area. This area is pi r L. This area is pi r square. So pi r L plus pi r square. That is called total surface area. Okay. Like that we are moving. Same figure. Let h be the height, r be the radius, L be the slant height, theta be the semi-vertical angle of the cone. Draw the figure. Write down. Let h be the height. Let h be the height. R be the base radius. R be the base radius. L be the slant height. L be the slant height. And theta be the semi-vertical angle of the cone. Semi-vertical angle of the cone. Angle of the cone. Right. Observe that ABC is right angle triangle. So apply Pythagoras theorem. So from triangle ABC, Pythagoras theorem, AC square is equal to AB square plus BC square. So AC square is equal to AB square plus BC square. AC square means L square is equal to H square plus R square. Okay. L square minus R square is equal to H square. Right. Take this as equation 1. According into data, surface area is given. Right. Surface area formula. Surface area of the cone. Surface area of the cone. S is equal to pi r L plus pi r square. This is pi r L. Cone is there, na? That area is pi r L. Under circle is there, circle. That area pi r square. Okay. S minus pi r square is equal to pi r L. S minus pi r square is equal to pi r L. L is equal to S minus pi r square divided by pi r. Okay, take this as equation 2. According into data, volume is maximum. So apply maximum minimum method for the volume of the cone. So volume of the cone Volume of the cone, comma, V is equal to 1 by 3 pi r square h. Pi r square h. Okay, squaring on both sides. To do this problem easily, so squaring on both sides. So V square is equal to 1 by 9 into pi square into r power 4 into h square, squaring on both sides. V square is equal to 1 by 3 whole square, 1 by 9, pi square, r power 4, h square. Substitute the data, make them into single variable. Right. So V square is equal to pi square by 9 into r power 4 into h square. H square. We know from equation 1, h square is L square minus r square. L square minus r square. Since from 1. No. Okay. V square is equal to pi square into r power 4 by 9 into L square. L we know. What is L is S minus pi r square by pi r. L value we know. So S minus pi r square divided by pi r whole square minus r square since from 2, right, is equal to pi square r power 4 by 9 into, this is take square to both numerator and denominator, S minus pi r square whole square by pi square r square minus r square, right, is equal to pi square r power 4 by 9 into, it is a minus b whole square formula. A square means s square, b square pi square r power 4, a square plus b square minus 2ab, 2s pi r square divided by pi square r square minus r square, right, is equal to pi square r power 4 by 9 into, take LCM. LCM is pi square r square, numerator s square plus pi square r power 4 minus 2s pi r square, pi square r square into r square, pi square r square into r square minus pi square r power 4. Okay, cancel it. Pi square r power 4, pi square r power 4 cancel. Here 1 pi square cancel, 1 r square also cancel, right, is equal to r square divided by 9 into s square minus 2s pi into r square, right, is equal to 1 by 9 into, multiply r square inside, s square r square minus 2s pi into r power 4. See that I changed into single variable because s is constant. Because given surface area given, I changed into single variable r. It is involved in r, so let us assume that this is f of r, function of r. Let apply maxima minima method for this function. Till now I changed only into single variable, not applied method. Apply. So f dash of r is equal to 1 by 9 constant, s square also constant, r square means 2r minus 2s pi constant, r power 4 is 4r cubed, okay, is equal to 1 by 9 into 2 s square r minus 2 4 ja 8 s pi r cubed. 2 4 ja 8 s pi r cubed. That is f dash of r. To get either maximum or minimum values equate to 0. So for maxima or minima, f dash of r is equal to 0. F dash of r means 1 by 9 into 2 s square r minus 8 s pi r cubed is equal to 0. Cross multiply 9 into 0, 0. So 2 s square r minus 8 s pi r cubed is equal to 0. From this what we are going to find r value. So differentiate with respect to r na. So find r value. So 2 s square r is equal to 8 s pi r cubed. Okay. 1 s cancel. 1 r cancel. S is equal to 8 pi r square by 2. S is equal to 4, 2 1 ja 2 4 ja 4 pi r square. S is equal to 4 pi r square. So r square is equal to s by 4 pi. R is equal to square become root of s by 4 pi. R is equal to root s by 2 into root pi. Okay, that is r value. Right. Again differentiate this one. Again differentiate. F double dash of r. F double dash of r. Again differentiation. So 1 by 9 constant into 2s square also constant. R derivative is 1 minus 8s pi constant. R cube derivative 3r square. R cube derivative 3r square. Okay. Put r value in f double dash x at r is equal to root s by 2 into root pi. F double dash of r is equal to 1 by 9 into 2s square minus 8 3 is 24 s pi r square. R value we know. R value is so r square is s by 4 pi. Right, 8 3 is 24 s pi. R square is s by 4 pi. Pi cancel. 4 1 ja 4 6 ja cancel. Is equal to 1 by 9 into 2s square minus 6s square is equal to 1 by 9 into minus 4s square is equal to minus 4s square by 9, which is less than 0. Less than 0. If it is less than 0, what can you say about the function is maximum? Therefore, volume is maximum. Maximum when r is equal to root s by 2 into root pi. I proved that volume is maximum, but I have to prove theta equal to sine inverse of 1 by 3. Sine formula is opposite side by hypotenuse. Opposite side r value, hypotenuse I want. So substitute in equation 2. So from 2 L is equal to s minus pi r square divided by pi r. Correct, ra? See that? L is equal to okay sir, last 2 steps they cannot understand. Correct, is equal to s value, s value is 4 pi r square. 4 pi r square. See the step, this step above is 4 pi r square is there. Minus pi r square divided by pi r is equal to 4 pi r square minus pi r square is 3 pi r square divided by pi r. Okay, pi cancel, 1 r also cancel, is equal to 3r. 3r. But I want sin theta formula. So from triangle ABC, right, from triangle ABC, sin theta formula is opposite side by hypotenuse. Opposite side by hypotenuse. So sin theta is equal to opposite side BC, hypotenuse AC. Right, sin theta is equal to BC value R, AC value L is equal to R. R same only. L we find 3R. L we find 3R. R cancel, 1 by 3. LHS side sin theta is there. Therefore, theta is equal to, send sin function to that side, it becomes sin inverse of 1 by 3. Sin inverse of 1 by 3. So, conclusion, hence, the volume of the cone will be maximum when theta is equal to sin inverse of 1 by 3. Okay, that is the complete problem. Okay, write it now. We will continue in next coming classes.
Good morning, children. Today I'll continue the remaining part in the topic coordination compounds. Yesterday we discussed a few points about coordination compounds related to Werner's theory of coordination compounds or complex compounds. The next topic is few important terms in coordination or complex compounds. I will explain one by one. Please note down and follow the class. Okay, children? Note down important terms in coordination compounds. See, I give one complex compound, children. CO NH3 6 Cl3. This is one complex compound. See, now apply the terms to the given compound. Here CO is cobalt, it is central metal atom or ion. Now outside sphere, this is called as coordination sphere. See this square bracket, which is called as what? Coordination sphere or coordination entity. Better write both coordination sphere or coordination entity or entity. Okay, central metal. Okay, this area, this square bracket, which is called as coordination sphere or coordination entity. So these NH3 molecules acts as ligands, LIGANDS. Outside sphere, these three chlorine atoms satisfies primary valence. This NH3 is secondary valence. The species which satisfies secondary valence is called as ligand or ligands. Okay, children, this is one complex compound. This CO is what? Central metal atom. NH3. How many NH3s? 6 ammonia given. These 6 ammonias NH3 molecules acts as ligand. LIGANDS. Ligands. Okay, nothing but secondary valence. Secondary valence, ligand, same. Outside sphere, these three chlorine atoms, primary valence. And this square bracket, this area is coordination sphere. Central metal plus ligand enclosed in square bracket. This area or part is coordination sphere, nothing but coordination entity, ENTITY. And one more, in this complex central metal atom or ion electron pair acceptor, hence it acts as Lewis acid, and ligand acts as Lewis base. Don't worry, I will explain all points. Just you give different terms to the given complex. First point, central metal. It has two valencies, primary valence, secondary valence. Yesterday I explained in Werner's theory. Primary valence outside sphere, secondary valence inside sphere. Primary valence is ionizable, secondary valence is non-ionizable. And these three chlorine atoms, primary valence, 6 ammonias, secondary valence. The species which satisfies secondary valence is nothing but ligand. Here ligand is electron pair donor, hence it is Lewis base, and central metal atom is electron pair acceptor, hence it is Lewis acid. Central metal or atom or ion and ligand enclosed in square bracket. This part is coordination entity or coordination sphere. And one more, primary valence tells the oxidation state of central metal in the complex compound. What is the primary valence? 3 chlorine atoms. So that's why here cobalt oxidation state is +3. Cobalt oxidation state is +3. How you decide +3? Why? Because primary valence is ionizable. It indicates or it describes oxidation state of Cm, central metal. Cobalt oxidation state is +3 in the given complex or compound. Okay, now we will discuss all the terms once again. The first term is coordination entity, ENTITY. Note down. Coordination entity means what, children? It contains central metal atom or ion and a fixed number of ions or molecules. Note down. Coordination entity. It contains central metal atom or ion and fixed number of ions or molecules. Okay, children, all these terms are important in theory. Define ligand, given example. What is coordination entity? Okay, children, and what is coordination number? Given example. Okay, you learn concept and statement also. What is coordination entity? It contains central metal atom or ion and a fixed number of ions or molecules. For example, same CO NH3 6 Cl3. Add same example. For example, cobalt NH3 6 times Cl3. In this complex, cobalt is the central metal surrounded by 6 ammonias and 3 chloride ions. Note down. In the above complex, CO is central metal surrounded by 6 NH3 and 3 Cl atoms. This is coordination entity. Next, very important term is ligand. Okay, children, note down. Second term is very important, ligand. Ligand nothing but electron pair donor, children. Ligand is the species, means ion or molecule which donates electron pair to central metal ion and forms coordinate bond is called as ligand. Simply, ligand is electron pair donor. What is the concept in ligand? Simply, it is electron pair donor to Cm. Cm is what? Central metal atom or ion. Note down. The species, define ligand. The species means either ion or molecule which donates, please underline donates, electron pair to central metal atom or ion and forms coordinate bond. Coordinate bond is ligand. Note down. The species means either ion or molecule which donates electron pair to central metal atom or ion and forms coordinate bond is ligand. Simply, what is the nature of ligand, children? Ligand is electron pair donor. Electron pair donor. According to Lewis theory, it is Lewis base. Better add one more point. What is the nature of ligand? It is Lewis base. In complex compound, central metal ion is Lewis acid. So ligand is electron pair donor and it is Lewis base. Based on number of lone pairs donating ability in the complex, ligands are monodentate, bidentate, tridentate, polydentate, or monodentate and polydentate. The ligand which donates one electron pair to central metal ion is monodentate ligand. If more than one electron pairs, then ligand is polydentate ligand. Now, this is the ligand, children. Now, write the types of ligands. What is ligand? The species means either ion or molecule which donates electron pair to central metal atom or ion and forms coordinate bond is ligand. Simply, the nature of ligand is electron pair donor, hence it is Lewis base. Now, types of ligands. Types of ligands. Note down. First one, monodentate ligand. Monodentate. Mono means what, children? One. The species which donate one lone pair or one electron pair. Note down. Monodentate. Ligand which donates one electron pair to Cm. Just write concept only, children. What is monodentate? Mono means one. Ligand which donates one electron pair to central metal ion or atom is monodentate ligand. Okay, generally monodentate ligands are again three types children. Based on charge, monodentate ligands are again neutral, negative or anionic, negative or anionic, third positive or cationic. Neutral ligands, examples NH3 and H2O. NH3 is ammonia and H2O is water. These two are monodentate. Why? Because these two ligands donate one electron pair to central metal atom or ion. Negative or anionic, examples Cl minus, Br minus, Cn minus. Negative charge, chloride ion, Br minus, bromide ion, Cn minus, cyanide ion. Okay children, these three are examples for negative or anionic. Next, cationic or positive, example NO plus, NO plus. So finally, what is monodentate ligand children? These are the ligands donates only one electron pair to central metal atom or ion. Based on the charges, these are again neutral, negative, positive or cationic. Neutral ligands NH3 and H2O, ammonia and H2O. Negative Cl minus, Br minus, Cn minus. Positive or cationic NO plus. All these are monodentate ligands. Next, polydentate. Polydentate means the ligand which donates more than one electron pairs to central metal atom or central metal ion in the complex is poly. Poly means what children? Donates more than one electron pairs to Cm. Again based on number, polydentate are again bidentate, tridentate, tetradentate like. Okay, most familiar bidentate ligand. Bidentate. Bi means what children? Mono or uni is one children. Bidentate means what? Two. Better just write one small statement. Bidentate ligand donates two electron pairs. E minus means electron pairs. Very important example is En. What is En? En is ethylene diamine. Very important in entrance. Among the following, which one is bidentate? NH3, H2O, Cl minus, En. En. Or En is monodentate, bidentate, tridentate, hexadentate. En is what children? En is ethylene diamine. Why En is ethylene? Bidentate. Why? Because the structure of En is ethylene means CH2, CH2. NH2 and NH2. See, this nitrogen one lone pair, another nitrogen, another lone pair. See, this is one bond, another bond. Understand? Bidentate means what children? Ligand donates two electron pairs to Cm. Example En. Full form of En is what? Ethylene diamine. This is the structure. CH2, CH2, NH2, NH2. This nitrogen contains one lone pair. It is one donor atom. This nitrogen, another donor. So that's why finally this is the ethylene diamine donates two electron pairs to Cm. Hence it is bidentate. Example 2. C2O4 2 minus. It is oxalate ion. Oxalate ion. Structure COO minus, COO minus. See? Example 2. This negative charge, one donor atom, this negative charge acts as another donor. So finally, Oxalate ion is what, children? C2O42 minus. How many donor atoms? See, donor sites, COO minus, COO minus. Negative charge, negative. So, 2 lone pairs or 2 electron pairs donates to Cm. So, finally, ethylene diamine and oxalate ion both are bidentate because these 2 ligands donate 2 electron pairs. Next, one more example for polydentate is hexadentate ligand. Hexadentate means ligand which donates 6 electron pairs to central metal atom or ion. Note down one more, hexadentate. Hexadentate ligand. Hexa means, what is the concept? Simple. Ligand donates 6 electron pairs to Cm. The best example for hexadentate ligand is EDTA4 minus. It's very important. I'll explain structure also. EDTA4 minus. What is EDTA? Ethylene. D means diamine. T means tetra. A is acetate. 4 minus ion. Charge na? Hence it is ion. What is full form of EDTA? Ethylene diamine tetraacetate 4 minus ion. Why it is hexadentate? I will give structure also. Note down, children. Ethylene CH2 CH2. Diamine nitrogen nitrogen. Tetraacetate. Acetate means here CH2 COO minus. This one CH2 COO minus. Again, this nitrogen also 2 acetate groups. Tetra. Tetra means how many acetate groups? 4. 1, 2. Next, CH2 COO minus. This one also CH2 COO minus. This is the complete structure of EDTA. Again, see, children, ethylene diamine tetraacetate 1, 2, 3, 4. Now come to the point. How many lone pairs, children? Electron pairs 6. How many donor atoms here? See, 1, okay, 2 negative charge, 3, 4, and nitrogen also having 1 lone pair, 5, and this nitrogen 6. How many donor sites? 1, 2, 3, 4, 5, 6. Finally, this is the ion donates 6 electron pairs, hence it is hexadentate or polydentate. Don't write any mistake. First you should write CH2, CH2, N, children. CH2 COO minus, CH2 COO minus. Again, this nitrogen also CH2 COO minus, and one more CH2 COO minus. Just to highlight donor sites. Donor site 1, 2, 3, 4, 5, 6. Finally, it is ethylene diamine tetraacetate ion. And in entrance, EDTA is hexadentate ligand. The number of donor sites, first option 6 oxygen, next 4 oxygen plus 2 nitrogen, 3 oxygen plus 3 nitrogen, and 6 nitrogen. In the entrance, EDTA is hexadentate, children. They don't give any structure. The question is EDTA is hexadentate and the donor sites are 4 options. What is the right answer, children? How many donor sites? Total 6. Out of 6 oxygen donor atoms, sites 1, 2, 3, 4. So finally 4 donor sites are oxygen, remaining 2 nitrogens. Better add this point. It has 2 types of donor sites. 4 oxygen and 2 nitrogen donor sites. Okay children, this is EDTA. Okay children, finally ligand is electron pair donor. Based on number of lone pairs or electron pairs in the complex, monodentate, bidentate, tridentate, hexadentate, like. Okay, and one more, flexidentate ligand. Flexidentate. Flexidentate nothing but the ligand or polydentate ligand behaves like different types. For example, see, don't confuse, SO4 2 minus children, this is sulfate ion. Actually, it is what? Bidentate. But in some cases, it is monodentate. So finally, sulfate ion acts as both bidentate as well as monodentate ligand. Hence, this is called as what? Flexidentate. Best example, EDTA. EDTA has how many electron pairs children? 6 donor sites. In some reactions, it is tetradentate. Some reactions or in some compounds, it is penta. In some, hexa. So finally, polydentate ligand behaves like bidentate, tridentate, tetradentate in different compounds is called as flexidentate. Note down, flexidentate. Direct example, sulfate ion is bidentate in few compounds. The same sulfate ion acts as monodentate ligand in few complexes or compounds. And example 2. Okay, EDTA has 6, but depends on given compound. It is either tetradentate or pentadentate or hexadentate. So one EDTA behaves like different types, either tetra or penta or hexa, depends on the given compound or nature of the compound. It is called as flexidentate ligand. Next, one more very important children, ambidentate ligand. Ambi, A-M-B-I-D-E-N-T-A-T-E, ambidentate. Ambidentate means the ligand which contains 2 donor sites. 2 donor sites. For example, see, NO2, ONO, NO2 minus, ONO minus. See, how many nitrogens here? 1, 1. Oxygen atoms 2, 2. But here donor site is what? Nitrogen. But in this, oxygen. Linkage is like linkage. Okay children, these two are ambidentate. For example, see, metal, nitrogen, oxygen. See here, donor site is nitrogen. This compound is nitrito N because nitrogen is donor. Same, M is metal, ONO. This is also nitrito, but donor atom is oxygen. This type of ligands are ambidentate. Note down, ambidentate. If any doubt, just add one statement. Ambidentate means ligand which contains 2 donor sites or donor atoms. This is monodentate. It is also monodentate. Don't confuse. Monodentate, but donor sites are 2. Ambidentate. MNO2, MONO. This is nitrito N, nitrito O. And one more example for ambidentate. See, M is metal, SCN, M, NCS. See children, what is the difference between these two? Here donor site is sulfur. Here donor site is nitrogen. But atoms are same. See, sulfur, sulfur, carbon, carbon, nitrogen, nitrogen. The difference is donor site. See, this is metal, thiocyaneto. This is isothiocyanate. Metal is M, donor site sulfur, here donor site is nitrogen. In first year organic we discussed a functional group cyanide and isocyanide, like donor sites based on, or if the ligand which contains two atoms forms day-2 bond or coordinate bond with metal is ambidentate. Example, NO2 ONO, SCN NCS, nitrito-N nitrito-O, thiocyanate isothiocyanate. These are the important points in ligand. Okay children, next term is coordination number. Coordination number. Coordination number nothing but the number of ligands or the number of atoms of ligands which are directly attached to central metal, which is called as coordination number. For example, CO NH36 Cl3. What is the coordination number? C number is 6. Why? Because number of ligands 6, number of secondary valency 6. So finally 6, 6, 6. This 6 is what? Coordination number. Add one statement. The number of atoms of ligands are directly attached to central metal. The number of atoms of ligands which are directly attached to central metal, which is called as coordination number. Just write same CONH36 Cl3. Just write coordination number of cobalt is 6. Coordination number of cobalt is 6. Simply keep in your mind, coordination number nothing but species which satisfies secondary valency is secondary valency number, or the species which donates electron pair and forms day-2 bond is ligand. The number of ligands are nothing but coordination number. Okay children, next coordination sphere. Coordination sphere. See, K4 FeCN6. This is complex split into 4K plus FeCN6 4 minus. This is coordination sphere. So coordination sphere means, note down, central metal and ligands are enclosed in square bracket is its coordination sphere. This area children, this square bracket, this combination is coordination sphere. Just try to understand the concept and read and remember statement. If you know the concept, statement is easy. What is the concept? Simple. Coordination sphere means what? Central metal and ligands both are enclosed in square bracket is nothing but coordination sphere. What about K plus? These 4 K plus ions are counter ions. Add one more term, counter ions. All terms are very, very, very important in both theory and entrance. Coordination sphere means what children? Central metal atom or ion and ligands are enclosed in square bracket is coordination sphere. The species or ions in outside sphere is counter ions. Better direct write example K4 FeCN6, 4K plus FeCN6 4 minus. This area is coordination sphere. These 4K plus or potassium ions are counter ions. Next, coordination polyhedron. Polyhedron. Coordination polyhedron. Simply, the spatial arrangement of ligands around the central metal, which is called as coordination polyhedron. Note down, the spatial arrangement of ligands around the central metal atom or ion is coordination polyhedron. Nothing but it tells the shape. It tells the shape of the complex. What is coordination polyhedron? The spatial arrangement of ligands around the central metal atom or ion. I'll give few examples. Metal 1, 2, 3, 4, 5, 6. How many ligands, children? 1. L is ligand, M is metal. 3, 4, 5, 6. How many ligands, children? 6. This is octahedral complex. Octahedral. How many ligands? 6 ligands. Okay. Next, if it is 4, 2 types, either tetrahedral or square planar. This is ML6. Shortcut ML6. Next, ML4 type, 2 types. Metal 1, 2, 3, 4. Ligand, 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 ligand. It is, the shape is tetrahedral. Sometimes few complexes are in square planar. Same, just you check 1, 2, 3, 4. 1, 2, 3, 4. This is also ML4. This is square planar. Depends on nature of the ligand. Just for clarification, what is polyhedron, children? The spatial arrangement of ligands around the central metal in the complex is nothing but polyhedron or coordination polyhedron. If the number of ligands are 6, the shape is octahedral. The number of ligands are 6. How many ligands, children? 1, 2, 3, 4, 5, 6. It is octahedral complex. If the number of ligands are 4, these are 2 types based on ligand. Okay, this topic is in VBT, children, just for reference, either tetrahedral or square planar. This is what? Tetrahedral, this is square planar. If it is 5, note down, ML5, square pyramidal. M 1, 2, 3, 4, 5. Ligand, 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 ligand. This is what? ML5. 1, 2, 3, 4, 5. This is square pyramidal complex or compound. Okay, children, don't confuse. ML6, 6 ligands, octahedral. 4 ligands, either tetrahedral or square planar. This is tetrahedral arrangement. This is square planar arrangement. If it is 5, square pyramidal, sometimes it is trigonal bipyramidal. Trigonal bipyramidal means like PCl5 structure. Okay, all these are related to polyhedron. Next, homoleptic complex. Homoleptic complex and heteroleptic complex. Okay, children, small term, very important. Homoleptic and hetero. Homo means what, children? Similar or same. Hetero, different. If complex contains 2 same or one kind of ligand is called as homoleptic. Note down, complex or coordination compound, complex which contains only one kind or one type of ligands is homoleptic. Hetero, complex which contains different, please highlight only one kind, different types of ligands are heteroleptic. Don't confuse. I give only one example, children. See, CO NH3 6Cl3, CO NH3 5Cl2. See, here total number of ligands are 6 ammonias. See, only NH3 acts as ligand, hence it is homoleptic. What about here? 5NH3 plus 1Cl, different ligands. Why? Because here Cl, yesterday I explained now, Cl satisfies both primary and secondary. Hence this Cl is also ligand. So different ligands, it is heteroleptic. Here only 6 NH3s acts as ligand, hence it is homoleptic, it is hetero. These two are very important in exams. What is homoleptic complex? Give an example. The complex which contains only one kind or one type of ligands are homoleptic. Best example, CONH3 6Cl3. In this cobalt, central metal, 6 ammonia's ligand, 3 Cl atoms, primary valency. This cobalt contains 6 ammonias, only one type, hence it is homoleptic. Hetero, different or not same or various. CONH3 5Cl Cl2. In this also cobalt coordination number 6, but out of 6, 5 ammonias, 1 chlorine. So this is homoleptic complex, this is hetero. Homoleptic, same type of ligand, one type of ligand. Heteroleptic, different types are not similar ligands, is heteroleptic. Okay, children, tomorrow I will continue the remaining part. Okay, thank you, good luck.
Very good morning, students. Welcome back to physics class. Very good. Right, in last class we have discussed about the basic idea about semiconducting materials, what are semiconductors, and introduction about the semiconductors. Now today I will start with the topic types of semiconductors. So what are the types of semiconductors? Right. Before going to discuss about types of semiconductor, what is semiconductor? Yesterday, what you got the knowledge is the semiconductor is a material which can allow the partial electric current. What is the reason behind that? There is a gap, energy gap between conduction band and valence band. What is the energy gap in semiconductor? That is approximately less than 3 electron volts. 3 electron volts. In insulators, it is greater than 3 electron volts. Right, ma? And what are the types of materials, elemental forms, compound forms? We have discussed about semiconductor. Now, the classification of semiconducting materials. What are the types of semiconducting materials? First, I will tell the classification. Semiconducting materials, semiconductors. So basically, semiconductors are two types. It's the basic Okay, so what are the types of semiconductors here? Intrinsic semiconductors and extrinsic semiconductors. The terminology is something complex, I think. Intrinsic, extrinsic, intrinsic and extrinsic semiconductors. Okay, these intrinsic semiconductors also called pure semiconductors or pure form of semiconductors. Pure semiconductors, okay sir? Better sir, Murli sir. Intrinsic semiconductors also called pure semiconductors. These semiconductors are called impure semiconductor, pure and impure semiconductors. So, again the impure semiconductors classified into two types. These are p-type semiconductors and n-type semiconductor. P-type and n-type semiconductor. It is the basic classification. Nothing you know, just classification I am telling you. Later I will explain about this. So basic idea, semiconductors, two types. So intrinsic semiconductor, extrinsic semiconductors. Intrinsic semiconductor also called pure form of semiconductor. Extrinsic semiconductor also called impure form. So again it is classified into two types, p-type semiconductor and n-type semiconductor. P-type means positive type, n-type means negative type. This is the idea. Now we will come for one by one. What are those? Okay, fine? Right. So we have an idea about individual atom and lattice. Lattice and individual atoms differences we know. Why? Because yesterday we have discussed about the differences between individual atom. So if you take any semiconductor like germanium or silicon, that valence is germanium silicon, valence is how much? 4. So that one germanium or silicon if you take, that valence is equals to 4. If you take another germanium or silicon, that valence is also 4. Like that, if you take number of germaniums, so all together forms one crystal. In that crystal I can consider as 4n valency crystal. Why? Because each valency is 4. Totally how many I have taken? N I have taken. So that I can say 4n valency crystal. So this is, I am trying to show the idea about the crystalline structure, the crystalline of the semiconductor. Yes, it's very beautiful diagram, especially it is just like rangoli. Yes, very fine. Yes, you can see this is what the crystalline of any semiconducting material. Wow, still, yes. Yes, very nice diagram. So, what the diagram is indicates here, see that these are all what? Everywhere you can take one what? The particular semiconducting material, either germanium or silicon. Germanium or silicon you can take here. Now see how these are sharing. Yesterday I have taken one diagram. Only one particular, this is classification, you know, for adjustment I am rubbing this. If you take one particular material, what happens? Silicon I am taking, this is silicon, only one. Here how many are there means 4 valence. 4 valence. So that same in crystal I am showing you, this is a silicon for example, this is a silicon. So actual valence is what? 4. 4. One silicon sharing with this is another silicon, this is another silicon, this is another, this is another. Totally how many? 1, 2, 3, this is what? 4. 4 silicons. So that it will contribute another electron, it will contribute another electron, it will contribute and it will contribute. So these all totally how many covalent bonds? 4 bonds. So now these silicon is satisfied. At the same time all neighbors atoms also satisfied. So this is the crystalline structure of the particular either silicon or germanium. Why? Because valence is same. Okay na? Clear. See that? This is only 4 valence. Remaining 4 supported by 4 silicons in crystal. So you can take everywhere. This is one silicon. It valence is 4. Remaining 4 electrons are contributed by remaining 4 silicons in lattice. So in such a way, all silicons are germanium, whatever it may be, satisfied by getting octet configuration. Okay, this is the idea. So the same I can show energy level diagram. Energy level diagram. It is very important to understand the structure. It is energy level diagram. Yes. In energy level, how many levels are there? Basically, how many are there, ma? 2 levels are there. What are the 2 levels? This is what? This is what? CB. Sorry, VB. This is VB. This is what? CB. VB means what? Valence band. CB means what? Conduction band. So what is meant by energy band? I said the group of energy levels considered as energy band. So here so many energies are there. So many energies are. What these energies? These energies are belongs to the electrons of valence. Valence electrons energy levels. This is another band. What is this another band? This is the group of energy levels of conduction. Okay. So here also electrons will present. Here also will electrons present, we know. Try to understand. This is a normal structure. So these are valence electrons. They have separate energy level. These are conduction electrons. So what are the uses of conduction electron? When external potential difference is applied, these electrons will participate in conduction, electric current. So these electrons are ready to participate in flow, current. Okay, clear? Fine. Now, in normal temperature, in a normal situation, means I am starting with 0 Kelvin. I am starting with 0 Kelvin. So I have a crystal of a germanium or silicon. This is my crystal. So many atoms are there. All atoms together satisfied in this crystal. Now, this crystal energy level diagram it is. Clear? Okay. At 0 Kelvin I am talking. Where I am talking? 0 Kelvin I am talking. Yes. At 0 Kelvin temperature, it is a very least temperature, you know. So there is no minimum energy also. So that what happens, you know, all electrons. So all electrons are here only. Where? In which band it is? Valence band. No electron is jumped to conduction band. Why? Because the minimum thermal energy is not supplied to the valence band electrons in my crystal. Okay, so that all are fixed at valence band only. So all are fixed at valence band only means we know that this is probably 3 electron volts. But yesterday I said if I take silicon forbidden gap, energy gap is how much I said? 1.1 electron volt. If I take germanium, how much I taken? 0.72 electron volts. So if my material is silicon, I said no, silicon, 1.1 electron volts. One more question they have asked in CBSE exam. What is meant by forbidden gap of silicon is 1.1 electron volt? What is meant by energy gap of silicon is 1.1 electron volt? That means if 1.1 electron volts of energy if you supply to these electrons can jump from valence band to conduction band. Then they can give electric current. What is the meaning of energy gap of silicon is 1.1 electron volts means what the meaning ma? Whenever the energy supplied to the valence electrons in silicon, how much is required? 1.1. Simply I can say to jump valence band to conduction band, this electron require how much energy? 1.1 electron volts in silicon. In germanium, 0.72. That is the meaning. Okay, fine. Right. Now at 0 Kelvin, what happens? All electrons are struck at valence band only. Can these electrons create electric current? No. The minimum current also not there. Why? Because only conductional electrons only can create electric current. So that the energy gap remains the same. At the situation energy gap also more. So that at 0 Kelvin, is there any conductional electrons? 0. Here what are the conductional electrons? 0. Valence electrons are maximum. Maximum means what? I said 4n. Each atom contributes 4. How many atoms I have? N atoms in my crystal. So totally how many electrons are present? 4n electrons are 4n valency electrons are present in valence band only. No electron is going to conduction band. Then what is the current? 0. Can I call now this material as an insulator? Yes. Why? Because no current, no conductional electrons. So that it's very important point at 0 Kelvin. At 0 Kelvin, semiconductor behaves as a insulator. Semiconductor behaves as a insulator. One important point ma, so many students are asking, sir, while explaining we have to write that notes or not means, better some points you can write it. Why? Because what the points require for examination, board examination only I am sending the notes. All explained points I cannot send. So whenever you require the points, you can note it down. Right. Right ma. So at 0 Kelvin, semiconducting material behaves as a insulator. This is the idea. Okay na? Right. That is the first. When temperature is little increases, as I said, from 0 Kelvin to it comes to room temperature. Room temperature means 27 degrees. 27 plus 273, that is 300 Kelvin. How many Kelvins? 300 kelvins. Not 300 I am telling. Meanwhile some temperature. It's a little increases. When temperature increases, what will happen in semiconductor? We will see. When temperature is increases, see, little amount of energy when we are giving. When the energy, what energy we are supplying? Thermal energy. Thermal energy. So heat energy. So when heat energy is supplied to these electrons, valence electrons, what will happen? When that energy is equals to 1.1 electron volt, then what will happen? These electron can reach to here. Now valence electron becomes conductional electrons. Here a very, very important thing we need to understand. This electron went there. This electron reached to here when temperature increases. So here, any electron? No. Here I kept one hole. What I kept here? Hole. It is the idea. First time you might be hear this word hole. What is meant by hole? Hole is a vacant created by electron. This is previously electron position, electron place. Now by getting energy, the electron jump into conduction band. So there is a vacant of electron. Vacancy of electron is called hole. What is hole? Vacancy of electron. Vacancy of electron. Vacancy of electron is called hole. Then hole is a positive charge or negative charge? Positive or negative? Electron is went. One electron is taken out from the surface. Then the surface gets positive. So in such a way, this is positive. Understand? Yes. What is hole? Hole is a vacancy created at valence band. Okay. Now conduction electrons are reaching one by one like that. Again, what will happen? This another hole. Again, this another hole. Again, like that. Holes are created at a valence band. Electrons are jumped to conduction band. Now, by applying external field, we may have a little current. So, on increasing temperature, the conductivity of a semiconductor increases. On increasing temperature, the conductivity of a semiconductor increases. It is a point to be noted. And one more thing, what? One special concept is came out. The holes are created at valence band. Then what are the charge carriers here? Not only electrons, holes also. Okay, what are the charge carriers here? Not only electrons. Electrons are creating at conduction band. Now, holes are created at valence band. Okay, now try to observe the thing. Is the number of holes are equals to electrons or not? One electron reached there means one hole. Another electron reached there means another hole. So how many electrons are reaching here? The same number of holes will be there or not? So that number of electrons is equals to number of holes. Number of electrons are is equals to number of holes. Okay. So number of positive charges are is equals to number of negative charges. So that this crystal, this material electrically neutral only. Why? Because nothing is more charge. Just the vacuums are created. These vacuums are called holes. We need to discuss two more points about hole. Hole is a vacancy created by electron. Holes are created at valence band. Hole is positively charged, and that mobility of hole is very less than that of electron. That is to be interested point. Mobility, in current electricity we have an idea. The mobility, moment of. So the speed of electron is so greater than that of holes. Okay, right. So number of electrons are is equals to number of holes. So charge carriers are same. So that this material, this semiconductor material is electrically neutral. So what about current here? Current I is equals to, we know that NE plus, NE means what? IE plus, I can write IH. What is IE, IH? Total current in a semiconductor, that is minute current maybe, the current is equals to current due to electrons plus current due to holes. Now you may get doubt. Sir, we know there will be a motion of electrons in conduction band. They can create current. Then how holes are creating current? Yes, we will see. So once this electron reached here, there is a hole. Once the hole is created, next electron also getting the same energy by temperature, so that this electron reaching here, this is hole. Okay, first these are all electrons. This electron reaching here. Now this is hole. Now this electron is jumps. Now this electron reaching here, it is fulfilled. Again reach here, it will jump. Next this electron reaching here. Next this electron reaching here. Next this electron reaching here. Understand? Now this electron reaching here. This electron reached here. This electron reached here. So electrons are going in this direction. Holes are coming means in this direction. Understand? This is motion of electron. This is motion of holes. This is motion of electron. This is motion of holes. Understand? Yes, we know positive charges are opposite direction of electric field. Opposite direction of electric field. Negative charges are in the direction of electric field. So this is the idea. So that total current I is equals to IE plus IH. But here what very important thing we need to understand is, what is this name of semiconductor? We are discussing about classification, no? Yes, this type of semiconductor is called intrinsic semiconductor, pure form of semiconductor. I did not mix any other material here. It is pure silicon. At 0 Kelvin we discussed, at 300 Kelvin we discussed, at room temperature. At 0 Kelvin it is nothing but insulator. At room temperature a little current it can produce. That is due to the combination of electrons plus holes. What are the charge carriers? In particular semiconductor in silicon, electrons plus holes. Here it is also called Ne is equals to NH. Ne is equals to NH. So there will be a point Ni, that is what? Ne, NH, that is equals to Ni square. It is very important point for objective. Ne into NH, that is Ni square. Means number of electrons into number of holes is equals to Ni square. Means why? Because this number is equals to this number, na? This number is equals to this number. So total value Ni square. Intrinsic, I for intrinsic, Ni square. So total number is same. So that in intrinsic semiconductor, what is the property? Intrinsic semiconductor also called pure form of semiconductor. Why? Because number of electrons are is equals to number of holes. Can we get conductivity, maximum conductivity? No, minimum electric current we have. Minimum electric current only. There is no conductivity here. Okay, so there is no other material added to this. This is what? Pure form of semiconductor. So can we use this type of pure semiconductors to make the products of electronics? No use. Why? Because this cannot create much conductivity. Understand? And it is under control of temperature. It is not control of ourselves. Understand? If temperature is increases, conductivity little increase. If temperature decreases, it become an insulator. So the pure form of semiconductor should not be under our control. These semiconductors under control of temperature, that is external energy. So that a pure form of intrinsic semiconductor, not at all. suggestible to make components or products of electronics, semiconducting materials. So then we have to go for any other thing. So what we have to do? You have to develop some extra charge carriers. Then only you can have the current. Then only you can improve the conductivity. So number of electrons are is equals to number of holes, no? So that there is no conductivity maximum. So if you can make variation, number of electrons are greater than number of holes, or number of holes are greater than number of electrons, then what we can, you can utilize this material for conduction. Understand? Number of holes, number of electrons are same, so that net current is very less and it is under control of temperature. These are the drawbacks of pure form of semiconductor. This pure form of semiconductor also called what ma? Intrinsic semiconductor. Then what I am asking you, then how can we modify this material? Yes, we can modify. Oh, how? If electrons density is something more, we can have conductivity. Or holes concentration is more, we can have conductivity. So now what is our situation? We need to increase either electrons density or holes density. Then what we have to do? We have to add some other material into semiconductor. What we have to do? We have to add some other material into semiconductor. Then we can make conductivity develops. This process is called, in general language also, if you add something to any material, that concept is called doping. What the concept is ma? Doping. So what is meant by doping? What is the use of this doping? Okay, so here I have written one formula which is important formula. I said Ne into NH is equals to Ni square. This is called mass action law. Mass action law. According to mass action law, this constant. Mass action law, right? Now what I am telling, one term is that is doping. What it is ma? Doping. What is meant by doping? Adding of some other material into semiconductor. Still I can develop the sentence, adding of impurity. Impurity means it is not dust. Just we are using the term. Means what? It is pure form of silicon. It is pure form of germanium. Semiconductor. If I am adding any other element, some X and some Y I am adding. Means in pure form if I add something means it will come impure, no? Impure means it is not like dust or something. It is some other material. So the adding of impurity to the pure semiconductor is called doping. Understand? The adding of impurity to the material is called doping. Then what type of material we can add? By adding that material, what will happen to the conductivity? That is our reason. That is second category. What? Extrinsic semiconductors. Intrinsic semiconductor means what ma? Pure form of semiconductors, no use. Now we are coming to the concept of extrinsic semiconductors, impure semiconductors. Just like I will tell an example, gold. You know gold, how we are measuring? 24 carats, 22 carats, 20 carats, 18 carats. That meaning what you know? Pure gold we cannot use to make ornaments. Because it is very hard. We cannot convert into thin wires like different structures. So, what the people are doing, they are adding some copper into the gold. How much copper they are adding into the gold, it will decide the carats. 22 carats, 20 carats, 24 carats means what? They are adding 20, that means a part, 0.02 grams of copper into the gold. So they are adding copper into the gold. Understand? Then only they can make ornaments. So pure gold is intrinsic. If you have 1 kg of gold also no use. When the people are adding into gold what? Copper, they can make ornaments. That is, carats may decrease, but what will happen? We can make ornaments. So here also we have pure semiconductors, no use. What we have to do? We have to add something. Then only we have conductivity. These are called impure materials. These are called extrinsic semiconductors. Okay, fine? Yes. Now, what are the types of these extrinsic semiconductors and what are the impurities? So, extrinsic semiconductor, two types I said. Extrinsic semiconductors, two types I said. P-type semiconductor and N-type semiconductor. P-type semiconductor and N-type semiconductor. Means what? Positive type, negative type. I said to develop conductivity, you can improve the number density of holes or the number density of electron. Then only you have the maximum conductivity. Okay, fine. Then silicon germanium is added with some other material. What is that material? Dopants. That materials are called what? Dopants. Dopant means what? The materials which we are using to impure the pure semiconductor. So now here P-type semiconductors, N-type semiconductors. First I will take N-type semiconductor. First what I am taking? N-type semiconductor. So what are the N-type semiconductor? Okay, just before going to about extrinsic semiconductor, about intrinsic semiconductor, only one more point I want to discuss with you. That is what? Here in energy level, you know, these are the two energy levels. This is what? This is what, ma? This is valence band. This is conduction band. Valence band and conduction band. One new concept is came here. That is what? Fermi energy level. What the concept is? Fermi energy level. So what is meant by Fermi energy level? So here we have two types of definitions. Fermi energy level means the energy gained by the electron or the maximum energy gained by the electron at 0 Kelvin is called Fermi energy level, or the average energy of what are present here in valence band generally. Valence band generally contains what? Holes. Holes are belongs to valence band. Electrons are belongs to conduction band. This is the idea or not? When the energy is applied to the material, these electrons are jumped there. So the average energy of holes at valence band or the average energy of electrons at conduction band is called what? Fermi energy level. Okay, once again see that. What is meant by Fermi energy level? The average energy. First I given one definition. At 0 Kelvin, the maximum energy gained by the electron. That is different. For better understanding, we can take general definition. What? The average energy of a holes in valence band or the average energy of electrons in conduction band. In conduction band, what is called Fermi energy level. Fermi energy level. And that means what? This average energy, this average energy. Now total Fermi energy level we comes where? So for example, this is 10, this is 10. Means what? This is the middle point, no? So that in diagram we can show that this is Fermi energy level in what? Intrinsic semiconductor. It's very important point. In intrinsic semiconductor, Fermi energy level comes between conduction band, valence band and conduction band. Between valence band and conduction band. Okay, so this is the idea about Fermi energy level. Okay, right. Now what is our concept is P-type semiconductor and N-type semiconductor. What that is? impure semiconductors, doping process dopants. So what are the dopants? The process of adding impurities to the semiconductor is called doping. That materials are called dopants. Dopants are two types. What are the two types of trivalent, pentavalent? What are the dopants? Trivalent, pentavalent. Tri means how much? 3. Third group elements. Third group. What are the third group? Boron, aluminum, gallium, indium. Okay? Third group elements. Pentavalent. Pentavalent means what, ma? Fifth group. Phosphorus, arsenic, antimony. Phosphorus, arsenic, antimony. So these are the materials. So we have trivalent, pentavalent impurities. See, these are not impurities, elements, you know. We are going to add these materials into semiconductors to make improvement of conductivity. Okay. So what are the types of dopants? Trivalent, pentavalent. Trivalent and pentavalent. Okay. Right. So that when you are adding trivalent, you will get p-type semiconductors. When you are adding pentavalent, you will get n-type semiconductor. I said p-type means what, ma? Positive type. N-type means what, ma? Negative type. So which dopants can give n-type semiconductor? Pentavalent. Pentavalent. What are the pentavalent impurities? Phosphorus, arsenic, antimony. Which dopants can produce positive type semiconductors? What? Trivalent. Boron, aluminum, gallium, indium. Now we need to discuss about the rules to adding. Whatever you want to add, if you add, the material cannot exist. For example, I have silicon. It have a particular crystal, particular shape. So as per that, we need to take the proportion of a impurity to add. So we need to concentrate about the construction and the size of the material also. Understand? For example, 10 grams of gold, we can add 0.2, 0.3 or 0.5 grams of copper. It will give ornaments looking nice. 10 grams of gold, if you add 1 kg of copper, is it correct to get ornaments? No, there will be a correct proportion. Even doping also, we need to take some measurements. We need to take a proper ratio of dopants. Understand? Yes. For example, in silicon only. So in silicon, I have one particular crystal. As per that, I have to select. It should be nearly 3 to 4 ppm. What is ppm? You know, part per million. That means what? 10 power 6 only, na? Million means 10 power 6 atoms of silicon if I have. Just how many I can add impurities? Either 3 or 4. In such a least values we need to add. Then there will be a no defect of that internal mechanism and structure of the crystal. You should not make disturb to the crystal by adding impurity. That is the point to be noted. We should not make disturbance. So 10 power 6 of silicon, just what I am adding? 3 to 4 impurities of either third group or fifth group. Okay, this is we need to know before going to do the process of doping. Okay, so this is the idea what we have discussed. Semiconductor types: intrinsic semiconductor, extrinsic semiconductor. Intrinsic semiconductors also called pure form of semiconductors. Extrinsic semiconductors are called impure form. Pure form of semiconductors cannot give maximum conductivity. At 0 Kelvin, semiconductor behaves as a insulator. Okay, yes. What is hole? Hole is a vacancy created at valence band. It is positively charged. Which mobility is more, electron or hole? Electron mobility is more. Which mass is more? Hole mass only more. As you know, positive charge. Okay, so this is the idea. Next, one more concept we have discussed, that is Fermi energy level. The average energy of a holes in valency band, the average energy of electrons at conduction band is called Fermi energy level. In intrinsic semiconductor, Fermi energy level comes between conduction band and valence band. What is doping? The adding of impurities to the semiconductor is called doping. These materials are called dopants. Dopants are two types. What? Trivalent, pentavalent. Trivalent can produce positive type materials, positive type semiconductors. Pentavalent can be produced negative type semiconductors. Okay. While doping, we need to concentrate the proportion. By doing the process of doping, we should not make the disturbance of the internal mechanism of a what? Crystal of semiconductor. So it is nearby what? 3 to 4 ppm parts per million. Then there is no disturbance, there is no effect of the original structure of a crystal. This is the idea. One more last instruction. In semiconductor, what we are using the values like numericals. Yesterday I have taken resistivity, conductivity. These are all approximation, not exact. Different standard reference books, they have given different values. Plus or minus 1, 2, 3% variation should come. You don't think about that. Okay? Right, thank you. Today we have one more class in afternoon. I will continue the same topic. Why? Because this lesson we have for unit test exam. I need to complete this lesson. And one more thing, what? This lesson, neat and regular, everything is same. There is no separation. Why? Because it is a theory based concept. Thank you. Have a nice day.
Good morning, children. Another class of genetics, and in this we have already started pedigree analysis in the last class, and in that what we studied is actually the any study of any particular trait from generation to generation. If you study in a particular family, then that is called as pedigree analysis. I'll repeat. If a particular trait, the inheritance of a particular trait in a family from generation to generation, if we are studying, then that is called as pedigree analysis. These diagrams must be giving some idea to you. You see, these are all different generations. These are the offsprings and how they again got the third generation. All these things are there. So here we are studying in a family, and from one generation to other like that, several generations we are studying. If we study like that several generations, then that will be called as your pedigree analysis. Okay. Now, in pedigree analysis, we have to actually know all different types of symbols that we have to use, because the questions will be in the symbolic manner. It will be like this only you will get, and from there some questions will be there and you will have to find it out. So anyhow, so first the symbols, if you don't understand, then we will not be able to do anything. And in the last class I symbols, how a male is represented, that is square box, empty square box. Unaffected male is, it is a square and unaffected. Then a circle represents female, same, empty it should be, it should not be shaded, then that is actually unaffected female. Then comes a diamond shape which is also empty, and that is also unaffected and sex unspecified. After that we saw all these three only shaded. Yesterday, please check up your notebook. Yesterday you have done these things. All these three, that is male, female and sex unspecified, that is, if it is shaded, then that becomes your affected ones. After this we will see one male and one female. If they are connected like this, that means it is mating. Now if there is a double line, here there would have been double line, means it is a consanguineous mating. That means the mating very closely related mating, right? Now other thing we have seen it, that see here one mating is seen, again here you are seeing another mating, and their children are this. So this is first generation, this is second generation, and this is third generation. In this diagram we have got three generations, and generations are always marked in this manner. Three generations. Here also one, this is two, and the last one is your third generation. So generation can be represented by numbers like this, Roman numbers. And today we are going to learn some more symbols. These symbols you have to note it down. Children, please note it down, then only it will be easier for you to understand. I will be explaining. Please start noting down this diagram. Whatever I have made, what symbols I have made, you have to note it down, then only we will be able to go ahead. Suppose an individual is adopted in the family, and if he is also included in this, then we have to represent him or that person in this manner, a square inside bracket, that is called adopted individual. Now in a heterozygous condition, in autosomal recessive inheritance, heterozygote should be represented like this. Heterozygous means there will be two genes will be there, two alleles will be there. These two, they will be representing. So heterozygotes for autosomal recessive, this is the representation. Now in case of hemophilia, about which we have already studied in the past in other chapters, but here again we are coming. So the mother usually, the female is usually carrier, because it is an X-linked recessive gene. So the carrier is represented by a circle, it is female, and the dot at the center means that lady is carrier. Next, sometimes a baby is lost. It is abortion takes place, the baby dies. Anywhere they can show that also, only to confuse you, because an aborted child will have actually no after, another generation, no carriage, no inheritance will not be there. That's why, but at times to confuse us or to represent some message to give us, this symbol is made a circle which is shaded with a slanting line, that is stillbirth or abortion. And here once it is abortion, the sex also unspecified. Abortion you remember, so sex is also unspecified. Now after this we are seeing another one, a square and a circle which is connected and that is again crossed, and this means the case is divorced case, it is divorce. Next we are coming, if a person is marrying more than one, then all that number of marriages is their family, his family only, and that can be represented in this manner. The male is having first marriage, you see this is represented first marriage, and this is your second marriage, and this is the third marriage. See, everything is connected, this and this are connected by single line, this and this is connected by single line, this and this is connected by a single line. So 1, 2, 3 marriages it is showing. And the last one, what symbol I am going to give you is these, none of these symbols are there in your book except this, that is carrier. Others are not there, so note it down. Sometimes only symbols do come and you may be asked what it is. Now last one is, see, a male symbol is there, a female symbol is there, and they are connected with dots, a dotted line. If it is dotted line, then that means it is extramarital union. Extramarital union. That means it is not marriage, but a person or a lady having another affair. Okay. Now we are going to start this pedigree analysis. As I have already told you, pedigree analysis means it is the study of a particular trait. That trait may be positive trait or a negative trait, the beneficial character or non-beneficial character, and this trait, all traits are always, according to Mendelian genetics, every trait is always connected with a gene, it is regulated with a gene. So it is always they are regulated by a gene, and if you study the trait in the continuous different generations, how they are inherited, they are going to the son or going to the daughter or going to both of them or whatever it is, all details if you are studying in a family for several generations, then that we call as family tree, and the study is called as your pedigree analysis. Pedigree analysis. Like this, a family tree may be given to you and you have to analyze everything. Is that clear? So this is what in Mendelian disorder, what happens if there is a gene which is, or if a person has got is affected by some trait, then definitely in him there will be a gene and which is regulating it. Is that clear? So such type of disorders which are related to directly gene, they are called as Mendelian disorders. These Mendelian disorders are again of two types. It can be made, one is Mendelian, it can be dominant type and it can be recessive type also. And Mendelian disorder is also attached or related to your autosomal, mainly autosomal, but allosomal cases also we will see indirectly. So anyhow, Mendelian disorders are mainly determined due to mutation of a single gene. It happens due to mutation of a single gene. Okay. Now we will see the pattern of inheritance if you are studying. Remember the same pedigree analysis only I am telling in different manner. The pattern of inheritance of a particular trait, if you are studying in a family from generation to generation, then that is called as your pedigree analysis. Now under Mendelian disorders, we have got several disorders. For example, you can note down, these are all examples of Mendelian disorders. You can note down these examples of Mendelian disorder. They can be in two ways, questions can come. One is related to this pedigree analysis, one is related to the disorders and their details, and another one is related directly only to terminologies, which is Mendelian, which is not Mendelian, in order to separate, segregate, identify. That way also it will be of use to you. So note down, first Mendelian disorder is hemophilia. In the list in your book also it is there. All of them, they are there in the textbook. So hemophilia. Another one is there, that is called cystic fibrosis. It is cystic fibrosis. Please note down. Please remember, children, repeatedly I am telling in every class, these classes are not to finish the syllabus exactly. It is to more necessary for your understanding. If you understand, then it will be of use than simply completing. So we are going very slow, and time is also given for your writing. So see these things. Hemophilia is the one first example given in your textbook, that is Mendelian disorder. Second one is cystic fibrosis. Now third one is sickle cell anemia. Regarding these diseases we will discuss afterwards. We have got hemophilia in detail, we have got sickle cell anemia in detail, we will be seeing, and even cystic fibrosis is there, but somewhere else is there. So now we will not discuss this, that will be discussed in that context. Now next one is their color blindness. Color blindness and your hemophilia both are on the same lines of principle. They both are more or less same. They are both X-linked recessive genes. They are X-linked recessive genes. Then next comes your phenylketonuria. Then comes thalassemia. These are all coming under your Mendelian disorders. Actually, there are more Mendelian disorders are there. For example, muscular dystrophy is there, skeletal dysplasia is there, still many more are there, but I am not adding them. Those things we will be learning during the NEET. NEET classes also are happening weekly, once or twice is there. So in that class, whenever it will come, by that time I will be discussing these things. So I hope all these things are very clear till this. Now I will continue with the symbol. Here a new word is there, propositus. If a circle, shaded circle with an arrow mark at the bottom on the left side is there, then that is called as propositus. Similarly, a male symbol and that is shaded with the same type of arrow at the bottom left side, it is also called as propositus. Now what is propositus? See here, look at here, I will try to tell you. In this case, actually we will see this character, what is there in the parent. This is, first one is always parent. In the parent, whatever is there, that is coming to here and coming to here. Then actually in which first time this disease is seen, found in generation to generation, from one generation to other generation. So this is one is the propositus. This one is the propositus. Mean this character is coming to another generation through these two individuals, these two offsprings. Mean the offsprings who carry from the parent or it is inherited to them, then those offsprings are called as what? Propositus. Now next one we will see how to identify the method of this identifying a person. How to identify a person means propositus. See, once again I am telling, here you are seeing the characters are not there. They are not affected, at least externally, phenotypically at least. Now when the first, from this to this generation it comes, second generation, we suddenly find a new character here. Means one gene which is actually a trait appeared for the first time here. So this will be the propositus in this particular pedigree analysis. Am I clear? First time whichever will be visible with the trait, showing the trait, that one will be called as propositus. And here see, here this one and this one are the propositus. Here they are not there, but here they are seen. So these are propositus, propositus. There the male one, propositus. The female one, you see here female one and here male one are there. So these are the symbols how we will recognize, how we will identify. That's why that method is given. Now these fellows are all children. So 1, 2, 3, they are generally numbered as 1, 2, 3. But the generation is numbered by Roman letters numbers 1, 2, 3. Am I clear? Always remember the generations are represented by Roman numbers 1, 2, 3. But if you talk about the offsprings, these are the offsprings and they are numbered as 1, 2, 3, 3 and 4. 1, 2, this is 3, this is 4 and this is 5. So only this diagram can be given to you and you will be asked in the second generation. In the second generation, how many children were there from the first generation? Carefully if you see, this is not, this is there. It is coming from here, so 1. This is coming from here, 2. Coming from here 3, coming from here 4. So total 4 we have got what in the second generation, the number of children are 4, isn't it? This is only for your identification, how you will identify, I am telling. Otherwise, you need not note down as 1, 2, 3, 4 now, because here are also there. So, from the second to third generation, here we are getting how many? 3 children are there of these 2 parents. Similarly, of these 2 parents, we are getting again 3 children here. So, in the third generation, total number of grandchildren to these will be actually 3 and 3, 6. Like that questions can be asked. How many grandchildren are there in the given following pedigree analysis may be asked. How many sons and daughters are there? They may be asking. Is that clear? How many marriages have taken place in this? Try to count the marriages. As I told you, a single line connecting a female and a male is one marriage. So this is one marriage. Here no. Here is there 1, 2, second marriage. Here is there third marriage. This is no. This is also no. Total how many marriages have taken place in this pedigree analysis? 3. 3 na? 1 and here 2 and here 3. That's all. And no more marriages are shown. Maybe here marriages may be there, but it is not shown to us. So like that, this is the methods of how to identify here. So you have to remember very carefully, the moment you get this pedicle chart, there one thing you do, you have to do it in rough, that the generations, how many are there, always mark. It is very easy, as you are seeing, one marriage, their children, means this, if this is first generation, this will be the second generation. If any one of these are marrying and their children are there, that will be third generation. And remember, don't feel that here this is second generation, 3 children, and this is also second generation, and we are getting in the third generation how many children? Here 3, 6. So grandchildren of this are how many? 6. Children of this are how many? Only 4. So like this, you have to remember, if you know the symbol, it will be easier. And who are affected? How many affected individuals are present here? This is 1 affected, this is 2 affected, this is 3 affected, this is 4 affected. Can you understand how to identify? Because the symbols I have given you yesterday already. Today also I have given all the symbols. So please remember these things. Then only you will be able to do this. Is that clear? So now we will see when something is X-linked or X-related, whether it is recessive gene, then what will happen? It will be carried always from a mother to the son. Remember. Always it will be carried from a female to male progeny. Please remember, write down it a statement. If it is what X-linked recessive gene we are talking about in the pedigree, then always you check whether you have done correctly or not. Always it will be from female to male progeny only. It will never go from female to female or male to male. It will be always from female to male. The character will go, the trait will go. Understand? Again, the pedigree analysis, one example is given here in the diagram that I will analyze, and that will be actually helpful to you. That I am going to analyze. One is autosomal dominant trait, another one is autosomal recessive trait. One is autosomal dominant trait, one is autosomal recessive trait. How they are happening, we will see. Please mark here first. This is what actually, this is autosomal dominant trait. This one, autosomal dominant trait. If the, very carefully listen to me, I am analyzing both, keeping this idea always should be there in your mind. In your mind it should be there. If it is autosomal dominant trait or it is a recessive trait, that you have to remember. Now 2 types are possible in this pedigree and Mendelian genetics. One is dominant, another one will be recessive possible. That's all, only 2 are possible. So we will see with one example, we will study autosomal dominant trait. Now before I go into autosomal dominant trait, you have already been taught Mendelian genetics in the other track. Manna sir has already told you. So whenever there is a character, you can say R. This is dominant pair and this is what? Recessive. In this, if it is red in color, it will be, color will be red, and here color is white, isn't it? White. But when it is crossing, you are getting RR. Very interestingly, even though they both are not dominant, with a single dominant presence, we are getting it as what? Red. So this line, why I chose this? Because you have studied in Mendelian genetics in the other track like this only. So you see here what? In dominant, in autosomal dominant, 1 is also enough to give the what? Trait, to show the trait. Now only means this also we can take, this also we can take. Now your question may be, sir, this also is giving red color, this also is giving red color. You say that we should take this, why not this? Please see, if both are R, any combination you make, this R with this or this R with this or this, always what you will get? Red only. So that's why that cannot be taken, because further generation always it will repeat that only. So it should not be taken. Rather what we have to do is, we are taking this only. Now we will go here and see this arrangement. Here you see this one is there. Dominant means it is, always remember, capital R and small r, because from there only the generation have to come. But if you make both of them RR, then there cannot be the trait. Trait will not be there, because it is a dominant character. Trait itself is dominant. If you make both of them dominant, then all these things will not be there. Always only one character will come. So the female is what actually here? Heterozygous condition. Heterozygous in your Mendelian genetics is what? Dominant only. Do you remember that? Capital T, small t is what? Tall only. So that's why this we have taken in this. In this first, what happened? They both are going to cross, and let us try to remember, whenever there will be what? This condition. What is this condition? Dominant condition and heterozygous condition. Whenever there is heterozygous condition, there will be what? Or there can be what? Shaded condition. There may be. There can be. Understand? Let us see here. Now, they got so many children they got, and this child is without any trait. You can see. That means from here small r has gone, and from here small r has gone. That's why this girl child is without anything. But in this boy, he is infected. You see, this is due to capital R. So capital R is there, and the other one is small r here, because both have to contribute. If this is contributing R for this trait, then this side the other will be only small r. So again this is heterozygous condition is your infected one. That means from here to here there is inheritance. From this to the son, here there is inheritance. Similarly, here also to the daughter the inheritance has gone. Am I clear? Because in Mendelian genetics we are not think about male and female, because autosomal, so they will go only to both. So here this one becomes capital R small r, and here it is becoming capital R small r. Apart from that, all small r are not affected, unaffected. Is that clear? Now from this generation, what is the name of the generation? Second generation. In the second generation we have got 1, 2, 3, 4 children. Out of that, half of them are affected and half of them are not affected. Is that clear? You may be asked, in the first generation, what is the percentage of boys or sons getting affected? You see and tell that. Total number is how many? 1, 2, 3, 4. Out of 4, how many sons are affected? Only 1. So what is the percentage? 9. Sons too, but affected ones. Affected ones is only 1. So total children percentage will be 25%. But among the sons, what is the percentage? It will be 50. Why? 2 sons only they have got. Out of that, 1 is affected. Means how many are affected? 50% of the sons are affected, but 25% of the children are affected. Am I clear to you all? Children are 4. See, I am marking 1. This is your 2. This is your 3. This is your 4. In this total 4, 2 boys are there, 2 girls are there. So now how many boys and how many girls means they are in 50%, 50% or 1:1 ratio. Okay. But only non-infected son 25%. Or non-infected among sons 50%. You are understanding? Among the sons means total number of sons only 2. Out of that, half means 1 is affected. So it will be 50%. But how many among the children? then it will be 25%. You are understanding me? Total children are, you see, this is one child, this is one child, this is one child, this is one child. So 4 children are there. Out of these 4 children, how many are boys unaffected? 25%. How many boys are affected? Same 25% only. Is that clear? Among the children. Same rule for girls also. How many of the total children girls are affected? 25. But among the girls, how many are affected? It will be 50% rate. Total 1 and 1 are there. 2 only. This is not. This is marriage. So this is one female, this is one female. Total female are 2. Out of that, how many are affected? 1. So among the girls, how many are affected means your answer should be 50%. But among all the children means it will be 25%. Am I clear? Now here you see this fellow is unaffected, this fellow is also unaffected. Is that clear? Now when both are unaffected, that means small r, then all their children will be unaffected because that gene is not coming. That gene is carried there only. Is that clear? Okay. So now in this case we will see one is infected, the other one is not infected. Female is infected, male is not. Now when these two are crossed, we are finding one girl child is affected, whereas both the boys which are there, they are not affected. In this pedigree analysis, last word is very important in this pedigree analysis. We are not talking about all of them. And next one I am going to talk about this one. Autosomal recessive trait. Autosomal recessive trait means what? Always remember, if both recessive are, actually the recessive is a factor, and then both the genes or both the alleles of the gene should be that only. So in this what he has taken is, he has taken recessive. When this R and this R will come together, then only the character will be expressed. So what he has given as heterozygous condition. Remember, whenever recessive, double recessive only will have the trait. But in this condition they will not have the trait because this R will depress this R will suppress this. So now these are from outside phenotype, they are not affected, but actually they are having the gene. Here also the same condition. Now what happens? This is the recessive gene and this recessive gene, these two if they come together, then the disease will be there. So now what we found, 1, 2, 3, 4, 5 children we have got here. 5 children. See, I am writing, this is 5, this is 4, this is 3, this is 2, this is 1. Now this parent, they got how many children? 5 children. Am I clear? You may ask, what is this? See, here this daughter is marrying. So this fellow is not from this family, he is from the outside family. Like this also they may ask question. How many members are there outside the family? Outside the family here is how many? Only 1 is there. Anyhow. So here you see, out of all these, this R and R have come here together. That's why this boy is affected. Am I clear? We are only making analysis of pedigree chart. The pedigree chart we are just analyzing. Remember this. Similarly, here a girl is not affected, another girl is affected. Here also the same condition, small r. You can go for Punnett square. There you will see if these things are coming, means out of 4, 2 will be affected and 2 will not be affected in this condition, definitely. Okay. Now these are there. In this generation, that is second generation, only one daughter has married to somebody who is again not affected, but he has got this gene, recessive gene he has got. So when these two recessive genes will come together, this recessive will come together, again there will be, a child will be affected. So now in the third generation, you see this is third generation, the boy has got both the recessive genes and he is actually affected. Am I clear? Whereas in these cases, recessive genes have not come together, they are away, and heterozygous condition means they will not be expressing the character. They will be in a way carrier if it is a female. In case of female, it will be a carrier. Am I clear? Now, but in this case what is happening? anyhow it is autosomal. So wherever this genes, these alleles are going, that will be having that effect. Am I clear? So this is how to find out. Yes, one more thing I would like to tell. These two diagrams what I have discussed here, this is from your book only, from your textbook only. In the textbook these two only are given, and they have been not been explained, they have been left like that, and this is the explanation of the entire pedigree channel. You have to understand this chart, pedigree chart, this family over the family. You have to study very carefully why I have taken this and why I take in some others another manner. This you have to understand always, remember. In this case it is what? Dominant. Dominant means only one is enough to express. Whereas here recessive means both of them should be there, then only it will be possible. Understand? Anyhow, now today we will continue, learn more about hemophilia. Pedigree analysis is completed. Problems will be there from different sources, material you can see and you can do if necessary. Otherwise no problem, simply leave. This is enough for you for PU. Only study these two, about that detail, whatever notes I gave under that. Means identification, how to know, find out. Everything you write down and keep making it in notes. Now genetics we will continue, genetics part 2 we will continue. The next one is hemophilia. This is important, write down the heading, hemophilia. Very, very important this is. In hemophilia what happens, you know? Actually this particular disease is a genetic one. It is, the gene is associated with X chromosome. X chromosome, do you know that X chromosome? They are actually sex chromosomes. With the X chromosome it is linked. The recessive gene, hemophilia is regulated by a recessive gene and it is linked with X chromosome. Remember this, X chromosome, it is linked with X chromosome. Linked with X chromosome. Now what happens actually? If a person is suffering from this disease, he will fail to synthesize a protein. Write down, in this disease, if a person is suffering from hemophilia, in this disease, if a person is suffering from hemophilia, a single protein involved in blood clotting is not synthesized. Full stop. Now what will happen in this, if at all a person is suffering from this? If there is a cut, small cut, then he will bleed and bleed. The bleeding will never stop, clotting will never take place and the person will die. Am I clear? In this, a small cut can lead to death. A small cut can lead to death by non-stop bleeding. By non-stop bleeding. And in this, remember always a carrier. Do you remember the carrier symbol is given this? This is carrier. So a carrier female may transmit this. The disease to son. Remember, always a carrier female only will transmit the gene to the son. Okay. Similarly, a female to become infected with hemophilic condition, a female hemophilic is a very, very rare condition. It is not seen usually. It may be in thousands or lakhs. One case may be there. Am I clear? I am repeating once again. A female hemophilic is a rare thing. Remember, write down. It is a very rare thing. A female hemophilic is a very rare thing. Then when a female will be hemophilic, condition write down. Her mother should be at least carrier and father should be hemophilic. This is the condition when a female will be having what? Hemophilia. Will be having hemophilia. Is that clear? Now this hemophilia is seen in a very royal family, Queen Victoria. Queen Victoria. Okay, this is seen in whom? Queen Victoria. Now I am going to do the most important part of this. Very carefully try to understand. Remember, a female is always represented by what? X and X. And male is represented by what? X and Y. Now the hemophilic condition is what related to which chromosome? X chromosome. So generally whenever this is there and this X chromosome is here. So what it is? It is a carrier or not? Because hemophilia is a recessive character. So one is affected means it is a carrier female. Carrier female. And here nothing is there. It is not, it cannot be Y related. They have got only one X and it is also not affected. That means he is a normal person. Here this lady is also a normal person for outside, for expression. But only she is carrying only one. The normal gene is H and that will be suppressing this one. Now we will see if this X is fertilized by this, again this fertilized by this. What will happen? Normal X, this is also normal X. In this case it is X, H and Y. You see both are normal or not? They are not carrier also. But now when this will be crossing, this will be XH and X and this will be XH and Y. Am I clear? So please see, here also it is present, here also it is present. Now in this case there is only one X. So if one X is there, then one recessive gene is enough. One is enough to give the character. So this son will be what? Hemophilic. Clear? Whereas the daughter will be carrier. Alright, daughter will be carrier. That means you see, from a mother who is a carrier infected, that character is coming to whom? Son. Mother to son it is coming, and father's normal condition is coming to daughter. Is that clear? Coming to daughter. That's why it is called crisscross. Mother to son and father to daughter. So it is called, write down, crisscross inheritance. Crisscross inheritance. Is that clear? Now this son has got the hemophilic gene already with him. Now this will, from here, whenever this fellow is marrying and sharing the what? This X, this chromosome. for the girl child, it will again go to the girl child. From the son it will go to the girl. So see here, from the mother it goes to the son, from son again it comes to again daughter or a woman. That means it is skipping from a girl to girl, it is not coming, from a girl to boy it is coming, from boy to again a girl it is coming, means it is skipping one generation. So it is also called as skip generation. Skip generation. Children, remember here this a small hint only it is given here. I am going to deal this again in separate heading that we will do, but for the time being, because it is related to this, I had to tell you this. But this I will repeat again. There was very less time. I thought that I could finish it, but anyhow it could not be done. I will repeat again your hemophilia cross. Hemophilia cross, I will again do it. It might have been done in your track too, but still then once again I will do it in the next class. For hemophilia I will do, and for other disease also details I will be giving you. Please read carefully. Don't waste your time. Thank you very much.
Good afternoon, children. So, hope you are doing well during this lockdown period. So, till now one track is going on. So, that is continuing by Mr. Satish. And now, this schedule, we are going to run two tracks. So, one track Satish Kumar will teach, then other track I am going to continue. Because till yesterday I was busy with NEET and JEE programs. So therefore that part is over. Now we have to go with two tracks. So one track sir will take and the other track have to continue. So before I start lesson, just a few guidelines I would like to give you. So far we have completed some chapters which are small chapters in my view. Suppose like metallurgy, biomolecules, right? Next, these are the two. Now it's continuing D and F block. That's also small chapter only. But coming chapters, when you compare this completed ones, the most important coordination compounds. So I am talking about entrance point of view, NEET and JEE. Now D and F block is going on. The continuation is coordination complexes. D and F block coordination complexes are very important for objective point of view. At least you are getting 3 to 4 questions. So in the previous year, from these 2 chapters, we found 5 questions. So therefore, at least 20 marks you can gain in the NEET examinations. So please concentrate on that. Right? So coordination complex is the last topic in the inorganic part. And when you come to physical and organic parts, one important chapter completed, that is alkyl halides and aryl halides. Now alcohols, phenols, ethers, aldehydes, ketones, carboxylic acids, amines and diazonium salts. So these are the 4 important chapters, organic part. 1 is completed, 3 left. And coming to physical chemistry part, so one important chapter completed, that is solutions. Still we have electrochemistry, chemical kinetics, solid state. 3 more important chapters are left in this physical chemistry. Total 6 major chapters are there, right, excluding complex compounds. So therefore, including complex compounds, we are left with 7 very, very important chapters. Definitely, we will try to cover these chapters within 3 months. Maximum 3 months needed, because we are getting just 7 classes per week. So definitely 28 classes per month, 3 months we need. So whatever it may be, so I advise all of you, please concentrate, work hard. Don't expect results without hard work. That never happened. You need to do the work day and night. Practice is very, very important. And don't feel that this is difficult, that is difficult. Everything will be easy if you practice, if you learn properly. If you feel difficulty, then you cannot learn. Right, children? So these are the few points. I think next week you are going to have UT2. So I posted the unit test syllabus. And again, same syllabus, we are going to write objective paper. That is by next week. Right, children? Now, in today's class, I start to organic part, alcohols, phenols and ethers. Alcohols, phenols, ethers. You see this, these are the 3 classes of compounds having different functional groups. You know that alcohols, it has the functional group OH. If it takes phenols, it also having OH, but this OH is attached to aromatic system. That's why it is AROH. When you take ethers, the oxygen with alkyl group, this is the functional group in the ethers, alkoxy groups. Alkoxy group. These are the 3 important class of compounds. Alcohols, one type of compounds, phenols, another type of compounds, and ethers, this is. Here see, when you observe alcohols and phenols, this is hydroxy groups, this is alkoxy group. That means hydrogen is replaced by alkyl group. That is alkoxy. That's why this is also joined with alcohols. So we have to study, because why we joined all these 3 together? Because they are showing similar characters. That's why these are joined together. Right, children? Now first we can see this alcohols. After that go for phenols, then go for ethers. Right, children? Now this alcoholic group, it's similar to water. When you take water, you know that this is a water. When I replace hydrogen with one alkyl group, then you will get alcohol. That means simply it is just like, it looks like a derivative of water. That is, alkyl derivative of water is nothing but alcohol. This is for remembrance, easy to remember. Similarities, when you remember a compound when comparing with other, then easily you can remember. So this is a water, it's a very familiar compound in which oxygen is bonded to two hydrogen atoms. In the same way, one hydrogen is substituted by one alkyl group, then you will get alcohol structure ROH, still oxygen having two lone pairs. And this type of systems, so these are the aliphatic compounds, aliphatic alcohols. Aliphatic alcohols, right? You know the alcohols, very common compounds. Every day we heard about these alcohols. Normally, the alcohol is used in the manufacturing of beverages, that is drinking alcohols. The most important use of alcohols is solvent. It is a very good industrial solvent because it dissolves so many covalent compounds. So that is the main advantage. It is not only meant for drinking purpose. That is secondary. Primary, it is a good solvent. Right? Now, when you take these alcohols, the general formula of alcohols. Normally, you have alkyl groups. This is a alkyl group, and this valency is satisfied by OH group. This is the OH group. That means we can write it as ROH. So this is alkyl group. The alkyl group to which we can attach OH group, then we get alcohol. If you write the formula, you know that alkyl group formula CnH2n plus 1. CnH2n plus 1, this is alkyl group OH. Or you can write it as CnH2n plus 2O. This is the general formula of alcohol, CnH2n plus 1 OH or CnH2n plus 2 O. Right? These are the general formula of alcohols. Right, children? Now, I take this classification first. Classification of alcohols. So there are different classification in this. First classification is based on number of OH groups. So based on number of OH groups attached to this alkyl group, depends on that we have various classifications. So in this first one is monohydric alcohols. Monohydric alcohols. You know, children, mono means one. That means these are the alcohols which contains one OH group. Only one OH groups. That is, these are the compounds contains one OH group. So let us see the example. Very familiar example. Simplest alkyl group is methyl and OH is attached. This is the simplest alcohol. That is methyl alcohol. If alkyl group, if I take ethyl group, that is CH3, CH2, OH. Then this is ethyl alcohol. I will take nomenclature afterwards. Just these are familiar to you. That's why I am not writing the names. Nomenclature I can teach after this. So this contains one OH group. This is also having one OH group. Similarly, CH3, CH2, CH2OH. Or you can write CH3, CH, CH3, OH. This is N-propyl alcohol, this is isopropyl alcohol. That means when you observe these compounds, there is only one OH group is present. That's the reason these are called as monohydric alcohols. That is the compounds which contain only one OH group, one OH, one OH, one OH, one OH. These are the monohydric alcohols. When you take second one, this is dihydric alcohols. So dihydric alcohols means the alcohol that contains two OH groups, two OH groups in that particular compound. The very familiar compound in this, that is CH2OH, CH2OH. You know that this is known as glycol or ethylene glycol. Ethylene glycol. So ethylene glycol is a very common dihydric alcohol, CH2OH and CH2OH. Generally, here the two OH groups are on two carbon atoms adjacent. If this OH group is here, then that becomes unstable. Whenever two OH groups are on same carbon, that compound mostly it's a unstable. But except one compound, that is chloral hydrate. Chloral hydrate is very stable due to some other reasons. So when we discuss that compound objective, we will see this. So that's why the two OH groups are on adjacent carbon atoms. Adjacent carbon atoms. When this is present on this, then definitely this becomes 2OH and OH. From this water is expelled. H2O will be expelled. It will be converted to some other group. So that is and all you can learn in future. Right? This is dihydric alcohol. You can write, suppose this is OH, OH. You can write like this, or you can write one more OH. See, OH, OH. 1, 2, this is 1, 3. This is propyl alcohol. So 2 are there. So 1, 2 diol. This is 1, 3 diol. Nomenclature we will see later. Next, third one, trihydric alcohols. Trihydric alcohols means the alcohol that contains 3 hydroxy groups. 3 hydroxy groups. Here also very familiar compound we have, that is CH2OH, CHOH, CH2OH. This is a trihydric alcohol, what do you call as glycerol. This is also very common alcohol, glycerol. 3 OH groups are present in this compound. So monohydric alcohols having one OH group, dihydric alcohols having 2 OH groups, trihydric alcohols having 3 OH groups. You know that all these 3 are attached to 3 different carbon atoms. Different carbon atoms. If more than 3, then we say that to polyhydric alcohols. Polyhydric alcohols. The polyhydric alcohols very familiar. One important one. You remember that one. Polyhydric alcohol. Sorbitol. You know this sorbitol, that is CH2OH, CHOH 4 times CH2OH. This is having 6 OH groups, which is called as sorbitol. Right? This is just like glucose. You know that glucose structure? Did you remember glucose? This you have completed. CHO 6 membered chain. This is 6 membered. 1, 2, 3, 4, 5, and last is CH2OH. And these are all having OH groups. HOH, the third carbon is different. HOH, OHH, then HOH, HOH. This is a glucose structure. CHO, CHOH, 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 CH2OH. Same structure. In place of CHO, just you take one more CH2OH, so that you will get the sorbitol structure. In place of this one, just you need to write CH2OH, same, CHOH, 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 CH2OH. These are the ones 1, 2, 3, 4, 5, 6. Third carbon should be different configurations. Right, children? This is sorbitol and this is glucol. Just it is having like glucose structure. And you know that this glucose is D configuration. D configuration. This is also D configurations. You know that the D configuration means the last but one carbon. This is the carbon. This can decide the configurations. With respect to last carbon, this is last but one carbon. To this carbon, OH group, which is present on right side, that is D configurations. This OH is on left side, that is called as L configuration. D and L, capital D, capital L, that represents configurations. Small d, small l, that gives information about optical activity of that particular compound. If small d represents dextrorotatory and small l represents levorotatory, that is optical activity. You have studied in the alkyl halides and aryl halides. Optically active compounds we have two types, D and L, or plus and minus. And here capital D, capital L are related to configurations, nowhere related to optical activity. Right, children? This is the classification. So we can classify the alcohols as monohydric, dihydric, trihydric and polyhydric alcohol. 1 hydroxy group and 2 hydroxy groups and 3 hydroxy groups and 6 hydroxy groups. I have given one polyhydric alcohol, one example I have given, because this was asked in the objective examinations. You need to remember the structure. Next classification, so we can classify this, that is sp3OH bond. That means OH group is attached to sp3 carbon. Again OH group is attached to sp2 carbon. Two types. That means the type of carbon to which OH group is attached. So we have sp3 hybridized and sp2 hybridized. So I take first sp3 hybridized. In that we will see the classifications. For example, if I take CH3OH, methyl alcohol. So in this case, this is the carbon which undergoes sp3 hybridization. So the OH group is attached to sp3 hybrid carbon. Similarly, one more example, CH3, CH2OH. CH3, CH2OH. This is also sp3 hybrid carbon. This is sp3 Again this is sp3. So OH is attached to sp3 hybrid carbon. Right children? Next, I take this one CH3, CH, OH, CH3. Now I write here also one more CH3, CH2, CH2, OH. This is the carbon sp3. sp3 carbon OH is attached. Now if we take this one, this is also sp3 carbon. sp3 hybridized carbon to which OH is attached. Right children? Next example, I take CH3, CH2, 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 OH. Similarly, CH3, CH3, CH, CH2, OH. Right? CH3, CHOH, CH2, CH3. In all these compounds, OH group is attached to sp3 hybridized carbon, sp3. This is also sp3 and this is also sp3. Now I take one more example, CH3, C, CH3, CH3, OH. Now if you observe all these three categories of compounds in which OH is attached to sp3 hybrid carbon. If I take the first group, right, when you observe this carbon, this carbon, this carbon, that means the carbon atoms which are sp3 hybridized to which OH group is attached, these are all primary carbons. These are all primary carbons. What is meant by primary carbon? Primary carbons. Primary carbon is the carbon which is attached to one more carbon atom or no other carbon atom. That is called as primary carbon. The carbon which is attached to one more carbon atom or no other carbon atom, because the second part, no other carbon atoms, that is essential for methanol, methyl alcohol. Already it has only one carbon atom, so it is not attached to any other carbon atom, but it is primary. So therefore the primary carbon is nothing but the carbon atom which is attached to one more carbon atom or no other carbon atom. So that is called a primary carbon atom. So therefore these are the primary alcohols. These are all primary alcohols. Right? See here, this is a primary, this is a primary, and this is also a primary. All are primary only. Right? Now when you come to here, this one. So in this case, again OH is attached to one carbon, this is primary. Here CH2OH, again it is primary. Right? That means N-butyl alcohol, isobutyl alcohol, these comes under primary. Now you come here, this is the carbon atom which is attached to two other carbons. So therefore it is a secondary. So this alcohol is secondary alcohol. Even though it is sp3 hybridized, but it is a secondary alcohol. Secondary alcohol. Now you see this one. This is a tertiary alcohol, tertiary butyl alcohol. This is a butyl alcohol in which OH is attached to the carbon. This is the carbon which is attached to two more carbons. So therefore this is a secondary carbon. That's why we say that this is secondary butyl alcohol. Secondary butyl alcohol. Names I give afterwards. Right children? So the OH group is attached to secondary carbon. So it is a secondary alcohol. This is secondary, and this is secondary. Because in these two compounds, OH is attached to the carbon and this carbon is at 2 carbon atoms, attached to 2 carbons. Next, when you come to this one, the OH is attached to a carbon which is attached to 3 more carbon atoms, 3 more. That's why it is called as tertiary alcohol. Tertiary alcohols. That means when you consider the alcohols in which the OH group is attached to sp3 hybridized carbon, in that case we have primary, secondary and tertiary alcohols. Primary, secondary, tertiary alcohols. Remember that primary alcohol, primary carbon, this is the carbon which is attached to 1 more carbon atom or no other carbon atoms. Secondary carbon atom, this is attached to 2 more carbon atoms. Tertiary, attached to 3 more carbon atoms. This is. Next classification, allylic alcohols. Allylic alcohols. You know that allylic group, CH2 double bond CH, CH3. This is a propene, that is one propene only. So in this case, this carbon is sp2 hybridized and this carbon is sp3 hybridized. So whenever an sp3 hybridized carbon is attached to double bonded carbon atom, then this carbon is called as allylic carbon. Allylic carbon. Right? So allyl radicals are reactive, whether it is allylic carbocation or allylic carbanion or allylic free radical, they are reactive and stable. Why they are stable? Because of resonance. Because of resonance. This is because adjacent to this there is a double bond, pi electrons. These pi electrons will participate in resonance. For example, if I take CH2 double bond CH, CH2 plus, you know that this is the allylic carbocation. Allylic carbocation is more stable than primary, secondary, tertiary. Why this is more stable? Because of resonance. See, this will be shifted here, then we will get to CH2 plus CH double bond CH2. These are the two resonance structure. Similarly carbanion, similarly free radical. This you studied in GOC. So this is the allylic group which is very very important in the organic reactions. Right children? So this is allylic. Then allylic alcohols means the OH group is attached to allylic carbon. Allylic carbon. That means CH2 double bond CH single bond CH2OH. This is allylic alcohol. Allylic alcohol. So what is allylic position? The sp3 hybridized carbon which is attached to sp2 hybridized carbon. That particular carbon is called as allylic carbon. And the hydrogens attached are allylic hydrogen. So in this case one hydrogen is substituted by OH, that is called as allylic alcohols. Allylic alcohols. Right children? So this is allylic alcohol. In the allylic alcohols, again we have primary, secondary, tertiary. In the allylic we have primary, secondary, tertiary. So you can guess what I have written on the board. So this is a allylic which is a primary, because allylic carbon is attached to one carbon only. So in the allylic it is primary. Can you write the secondary? Yes, you can write very easily. CH2 double bond CH. Don't change this one children. Don't change the structure. This is the allylic. You know that CH2OH. So here carbon is attached to one carbon. So I want to make it to secondary. Just one more hydrogen you replace with one alkyl group. I take methyl, suppose any alkyl group. So now you see this carbon. This is a carbon which is attached to secondary carbon, double bonded carbon. So definitely this is allylic carbon, allylic. And to this, one is OH, one is hydrogen, one is, this is compound CH2 double bond CH group, right? And one more is CH3. That means this is the carbon attached to two carbons. So therefore this is a secondary, allylic but secondary, allylic but secondary alcohol. Now I can write tertiary also. CH2 double bond CH, OH. I can take methyl and I can take one more methyl, or you can write ethyl also. R dash, whatever it may be. Now this is a tertiary. It is allylic, again tertiary, right? So these are the classification of allylic alcohols. Remember children, allylic alcohols means the alcohol in which the OH group, alcoholic group is attached to allylic carbon. What is allylic carbon? Allylic carbon is sp3 hybridized carbon which is attached to sp2 hybridized carbon. This is must, you have to remember, right? In that allylic alcohols we have primary, secondary and tertiary. The first one, that is allylic primary, right? This one. And this is allylic secondary and this is allylic tertiary. Allylic tertiary. Right. Next classification, benzylic. Benzylic alcohols. You know that benzene, this is the benzene. H. So this is methyl benzene or toluene. Methyl benzene. This is the benzene nucleus and to this one side chain is there. This is side chain is methyl group. So from this, from the side chain, if I remove one hydrogen, then this is called as benzyl group. Benzyl. Right children? If I remove two hydrogens from this C, this is H and two valencies are, this is benzol group, benzol. And if I remove all the three hydrogens, then this is called as benzo group. So benzyl, benzol, benzo. These are the three groups we can get from toluene. This is the side chain methyl group. It is a sp3 hybridized carbon, right? Again this is sp3 attached to sp2. This is the thing. sp3 hybridized carbon attached to sp2 hybridized carbon. Same. sp3 hybridized carbon attached to sp2 hybridized carbon. But here it is the aliphatic compound. But this is aromatic ring. Right children? Right. But very important, remember that sp3 hybridized carbon is attached to sp2, sp3 attached to sp2. Since it is allyl and this is benzylic, it is attached to benzylic. In the benzylic, this is called as benzyl structure. Benzyl structure. So to this, when I add attached OH, this is called as benzyl alcohol. Benzyl alcohol. So I write third one here. Benzo. So therefore this is a benzyl alcohol, and here write two alkyl groups are there. This is right, children, and here this can be replaced by this OH group, that is called as benzo alcohol. Right, here three are there, one should be OH, and here you can have OH, because carbon is attached to one carbon, two carbons, again 1 2. Here this carbon is attached to 1 2, so you can take R and OH. This is benzo. So benzyl alcohol, benzyl alcohol, benzo alcohols, these are all comes under this is benzylic category. Here you can see this. This is the benzyl structure, this is benzyl structure, that is benzo structure. All are monohydric alcohols only. Right, children? Benzyl group, benzyl group, benzo group. These are the classifications. And this stability, when you compare the stability, benzyl carbocation is again more stable than that one. This is also we studied in the first year. When you say this one, HHOH, you know that oxygen carries a lone pair electrons in conjugation with benzene ring. Then what will happen? Here the electrons are in conjugation with this benzene ring. So therefore this shows plus R. Right? CH2 plus. This one benzyl group, not alcohol. When you take, children, this is benzyl group. This benzyl group cation, since it is cation, this will be resonance like this. That means the electrons are shifted towards the carbon, not the OH groups. OH groups of benzyl, that OH group is that. Alcohol is that, but benzyl, this is the cation, not the previous one. Now these electrons are shifted, then you will get a resonance structure CH2, this will be plus. Right, children? So again this will be shifted, right, this will be shifted. These structures already you know it, this and all first year we have studied. This again when you come to this stabilities we can discuss. Right, of course benzyl is more stable when compared to this one. When you take this one, allylic CH2 plus. Right. When you compare this and this is more stable when compared to this, because here you have three such type of resonance structures. If you want to write resonance structures, you can write, already you studied in the first year, CH2, this will be plus and this will be, sorry, CH2 double bond, like this. And again you will have, when you take this will be shifted, so you will get a double bond here, CH2, here you will get plus, this is the one. Then this will be shifted here, so that you can have double bond here, CH2, like this, right, plus. Then this will be shifted, finally we get the same compound. This is double bond, this is double bond, this is double bond, CH2 plus. Right, children? So benzyl carbocation is stabilized due to resonance. Benzyl carbocation is stabilized due to resonance structure. That's why benzyl is more stable than allylic. This is important bit too for the first year. That is stability order. Stability order, when you discuss, you need to this one. Right, children? And finally, one more is there. That is sp2 hybridized carbon OH. This is vinylic alcohol, CH2 double bond CHOH. Now OH group is attached directly to sp2 hybridized carbon. This is vinyl alcohol. Vinyl alcohol. That means OH group is attached to sp2 hybridized carbon. This is nothing but vinyl alcohol. Normally vinyl alcohol is somewhat unstable because this will be tautomerized. When this tautomerized, then you will get CH3 C double bond OH. It will be tautomerized to aldehyde. So in this we have keto group. So in this, right, we have alcohol group and there is a double bond. So we have enol. So this is keto enol isomers. So this is very important bit for objective examinations. This is vinyl alcohol. It is unstable and the stable form of this one is acetaldehyde, which is a keto form, and these are interconvertible and these are called as ketoenol isomers, and this is ketoenol isomerism, very important bit, remember that. So this is sp2OH, and one more is there, OH. You know that this is sp2. OH is directly attached to sp2. This is called as phenol. This is a aromatic system. So this we will study separately. Right, children? OH group is attached to unsaturated system. In that one compound is this sp2OH. This is also sp2OH, and this is comes under alcohol, but this comes under phenols. Phenols are studied as a different functional group. So this we will study separately. Just I have completed by comparing this and this. Phenol we have separate topic, we will study this. So therefore this is the vinylic alcohol in which OH is attached to sp2 hybridized carbon. So finally what we have discussed in this class today, simply alcohols classification as mono, di, tri. Mono 1 OH group, di 2 OH groups. I have given examples. There 3 OH groups. In this again next classification, sp3OH bonds. In this sp3OH bonds we have primary, we have secondary, we have tertiary. This is one more classification. Again next classification, in this only sp3OH, allylic and benzylic. Allylic, benzylic. So this is the structure that CH2 double bond CH, CH2OH, and this is the structure that C6H5 CH2OH. These are the structures. Again in this we have primary, secondary, tertiary. Primary, secondary, tertiary. And then after that this is vinylic, right? This is phenol separately. Again, in this case, I have given stability orders. That is allylic CH2 double bond CH, CH2 plus. This is the carbocation. Again, C6H5, CH2 plus, or C6H5, CH2 plus. These two are stable due to resonance. These two are stable due to resonance. When you compare this one, this is more stable than this one. More stable than this one. Right, children? In this I have given compounds. These are also important. You remember that CH2, this is benzyl group. This is CH, benzyl group. And this is C, 3 valencies are free, that is benzo group. So this is the synopsis for today's class. Just you need to remember and practice it. Next class I take the nomenclature. So when we complete nomenclature and start the preparations, properties and uses. Children, just you have to practice all these things for today's class. The next class, by the time you come to class, you must be upgraded this part, because this is a continuation. Organic part, it seems to be very easy, but it is difficult when you close the book. Just learn these points, right? Close the book, write it. Then only you can practice. While writing, don't open the book. After writing, just you compare. You need to practice all these things. There is no important that don't ask for an important one, unimportant ones. You have to learn 100%, right? Whatever we are teaching, you have to learn for an objective point of view, right, children? See you in the next class.